Hi, everyone. Good morning, good afternoon, good evening, wherever you are. Welcome to the very first Cosmos DB conference. This is the second session, meaning the Asia APAC friendly time zone. A couple of hours we had the US time zone friendly sessions. We had about 5 sessions and keynote. So here we are for the next batch. I'm Saranya. I'm a principal PM lead on the Cosmos DB team. And I'm super excited to be here to host the session for the Asia time zone. I have my colleague, Ben, here with me. And hey, Ben, go ahead. You want to introduce yourself?
Hi, everyone. Welcome to Cosmos DB conference. My name is Ben Griffin. I work at Microsoft as a technical specialist focusing on Cosmos DB. So I'm very delighted to be hosting here with Saranya today. So the format of the conference for this afternoon session for APAC is about 5 live sessions, all ranging from different topics around analytics to GraphQL to some real-time analytical processing, or even around some other fascinating topics. I can't think of them all because I'm so excited. But I'll hand it back to Saranya to talk a bit more about how you can answer post questions and look at some general housekeeping.
Sure. Yeah, great. So each of these sessions are quick. They're about 25-minute session, all delivered by our community, MVPs, and our customers or partners. So you really enjoy these coming from the external audiences. Then we'll have chance to answer a couple of questions, but please feel free to start posting in your questions on the chat. Ben, myself, we have experts around us. We will go ahead and answer them on the chat as well. With that, let's get started with the very first session. A quick housekeeping tip is we are on the Twitter hashtag #CosmosDBConf. Feel free to tweet about us or share, give us feedback. Welcome. Your comments are completely welcome. With that, let's move on to the very first session. This first session for today is about developing HTAP, which is Hybrid Transactional Analytical Processing Systems, analytical solutions with Azure Cosmos Database and Azure Synapse Analytics. Very excited to have Will Valida, who is a software engineer for the ASB Bank. More importantly, he is also a Microsoft Data Platform MVP based out of New Zealand. And here he is. He's been hacking, building multiple projects. He's been working on Cosmos DB in the past. And I'm very excited to see what he's got to show for us here. Will, over to you.
Awesome. Thank you very much. Just a quick note, I've actually changed jobs. I'm now an Azure integration consultant working out of Datacom, still based out in New Zealand and still a data platform MVP for now, touch wood. But welcome everyone to this session, developing high transactional and analytical processing analytical solutions with Azure Cosmos DB and Azure Synapse Analytics. I'm really excited to be actually talking about this subject to you all today, because this has been a pain point for me as a developer for quite some time. So I'll be developing applications for Cosmos DB, and it's fantastic for that flexibility, being able to iterate and actually develop applications really quickly using it. But then when my friends in analytics come to me and ask, okay, we want to do some analytics on your data in Cosmos DB, it's been a bit of a challenge, and Azure Synapse Analytics really solves those challenges for us. Just to give some expectations about this session, it doesn't really matter if you're an expert in Azure Cosmos DB. It doesn't matter if you haven't had a lot of experience with Synapse Analytics, if you're just brand new to either one of these topics. All I'm going to be doing today is just really showing you how you can build hybrid transactional analytical solutions really, really easily using Synapse Link for Azure Cosmos DB. So just to start off, I'll talk a little bit about the past. I'll talk a little bit about what it was like to build and to run analytics on Cosmos DB data before Synapse Link, and some of the pain points that I certainly experienced while attempting to do so. And then we'll kick off straight into what is Synapse Link for Cosmos DB. And then part of that story is really telling you about the new Azure Cosmos DB analytical store and what that is, and actually how that makes our lives so much easier when we're performing analytics on our Cosmos DB data. And then after that, I'll just kick off straight into a demo. As we go along, feel free to pop your questions in the chat, and after the presentation, we'll answer them at the end. Cool. So let's talk about limitations of performing analytics before Azure Synapse Link. So the way that throughput works in Cosmos DB, this would put a little bit of a bit of a pain point on us as developers. Whenever we're performing queries, optimal queries are really performed within the scope of a petition. So say if I had a container of hotels and I was petitioning that by city name, and if I wanted to perform some transactional queries against hotels that were based in Auckland, this was really straightforward to do, because we would just specify the city name as our petition key, and we were able to do that. But traditional analytics doesn't really work like that. We don't really, we don't often perform, we'd like to perform queries beyond the scope of a single petition. And in order to do this, previously, we'd have to perform really, really expensive compute-heavy cross-petition queries. And in order to actually do this, we would find that we'd have to provision extra request units in order to actually do this. And this is just a waste of resources. It's also a little bit of waste of money as well if we're performing these massive analytical queries on our transactional data when we don't really need to do this. In Cosmos DB, as some of you may know, indexing is automatically managed for us. However, depending on the size of the documents or the size of our data that we're persisting in Cosmos DB, and also depending on the consistency level that we set our Cosmos DB accounts at, this does have an effect on our request unit consumption. As a developer, I found myself kind of manipulating and really coming up with extensive indexing strategies depending on what type of queries I was performing, just to try and get some optimal performance out of those queries. And while this is possible, it does seem like we're over-engineering just to do some basic analytics on our Cosmos DB data. And this is all part of the need to actually develop complex ETL jobs in order to perform analytics, maybe materialize our data and actually manipulate and transform our data in order to perform those analytical to fulfill those analytical requirements. And we can do this using the change feed in Cosmos DB. We can use this, do this in Data Factory. There might be some other ways that we can extract our data out of Cosmos DB and persist it to more analytical friendly platforms. But again, this is over engineering and seems like a waste of time. And this is where Azure Synapse Link integration comes to the rescue. So essentially, Azure Synapse Link for Cosmos DB is a hybrid transactional and analytical processing capability that allows us to run near real-time analytics over our operational data in Azure Cosmos DB. It integrates Cosmos DB and Synapse and Azure Synapse Analytics really seamlessly. Essentially now, Cosmos DB has a feature called the Analytical Store, which is a fully isolated column-based store that enables us to perform analytics on our Cosmos DB data, requiring no ETL on our part to perform analytics on our operational data. We can use either Synapse Spark or SQL to run business intelligence, machine learning, or analytical workloads on our data without impacting the performance of our transactional workloads in Azure Cosmos DB. And this really reduces the complexity for us as developers. So we don't have to spend time in building our own ETL jobs. Azure Synapse Link allows us to directly access our analytical store without having to create those ETL jobs. Any updates on our transactional data will be visible to the analytical store within near real time without us having to develop those ETL jobs, for example, using the change feed. Now, ETL systems usually take a while to get the results that we want due to the complex nature of the ETL jobs. With Synapse Link, we can analyze our operational data in near real time, which opens up some really, really interesting analytical scenarios for us. So instead of having to transform the data, we can just enable the analytical store on our Cosmos DB containers and produce the data as is to our users, and then they can analyze that data, work on that data without affecting our transactional workloads. And in the past, this is really handy because in the past, we'd have to provision either additional throughput on our Cosmos DB account to perform those analytical jobs or implement the change feed to pick up that data and store it elsewhere. With Synapse Link, we can run analytical queries against our analytical store in Cosmos DB and leaving our transactional workloads isolated just to do their thing on a global scale if we need to. So in order to solve our issues with the transactional or data store, the Cosmos DB team announced the analytical column store feature. And essentially what this is, it addresses the complexity and latency challenges that I described earlier with our row store. And you can automatically sync your operational data into a separate column store, which is more suited to analytical queries, requiring no ETL on our part, no change feed. This is just asynchronous. When we enable the analytical store on a Cosmos DB container, a new column store is created, is internally created based on your operational data, the operational data within your container. This is persisted separately from our transactional store for that container. There's no impact on our performance for transactional workloads. So if we need to perform really complex analytical queries, we don't need to allocate any extra request units for that. We're essentially just querying the analytical store, and our transactional workloads are isolated. Now, the data from our transactional store is automatically synced to our analytical store within a 5-minute time gap, so it's fairly real time. Now, you may be wondering, since Cosmos DB is a NoSQL database service and doesn't worry about schema management, how can we actually manage this in Azure Synapse? Essentially, what the analytical store does, it's optimized for analytical query performance. Meaning that with the auto sync capability, what Cosmos DB will do, it will manage the schema inference, which includes any nested properties. So when our schema changes in Cosmos DB, the analytical store will automatically present a unionized schema across all of our historical schemas within our transactional store. Now, for those of you who may be a little bit more familiar with Cosmos DB, you may know of this concept of time to live, which is essentially a configuration setting that we can set either on our item basis or a container basis for our transactional data. And essentially, we can set that either at the item or container level. And that essentially says, okay, after so many seconds, we can either delete this item or delete the data in this container. Well, this option is now also available for us for our data sitting in the analytical store. It might just be at the container level at the time. It might have moved to items. I'm not sure, but I know definitely at the container level we can enable the analytical time to live. So essentially, inserts, updates, and deletes to our operational data are synced to our analytical store, irrespective of our transactional time to live. So we can specify how long we want to retain data in our analytical store using the analytical time to live. And then once we've enabled that analytical time to live value, we can actually update that with a different value later if we need to. So we could be in situations where we'll have writes going to our transactional store. We might have optimized a container purely for writes. We enable the analytical store on that container. And then for our transactional time to live, we set that at a lower level at a smaller setting to our analytical time to live. So it's retained longer within our analytical store compared to our transactional store. All right, let's kick off into a demo. So in this demo, what I'm going to show all of you is how to actually create a container in Azure Cosmos DB with the analytical store enabled. Then we're going to jump into Azure Synapse and we're going to start querying that data using Synapse Spark. So let me move there. Okay, cool. So here I am in Azure Cosmos DB. And as you can see, I've already built a demo. So if anyone's watched that show, there was a show in the UK. I'm not sure if I can say it on Learn TV, but essentially here's one I built earlier. But what we're going to do, we're going to create a new container. And hopefully, so essentially all I'm going to be doing for this is just showing you how really simple it is and straightforward it is to enable the analytical store via the portal. And if you're using infrastructure as code tools, you can do this as well. So I'll just call it stock demo container. We won't be persisting any data in here. And here we go. So using this setting analytical store, we can just enable that on and off. And then I'll show you how you can differentiate between different containers in Azure Synapse to see which ones haven't got the analytical store enabled and which ones have. Here, we're just enabling it for on. So we'll let that create in the background. And essentially now, when we look into the settings within Cosmos DB, for those of you who are familiar with the portal, you can actually configure the settings onto your container via the portal. So if I go into that stock demo container, if I go into settings, here we should see two different options. So here's my time to live. So that's for our transactional data. And I can set that, configure that in seconds. I can just stick that on for no default. And then here I've got analytical storage time to live. So say if this was the right optimized container, I could literally just put 30 seconds. So after 30 seconds, items within this container would be deleted in our transactional store. And then on our analytical storage time to live, I might, I was going to put 7 years in seconds, but essentially I can set the analytical store to retain our data a little bit longer than our transactional store. So if we wanted to optimize the storage, we can, that's just one way that we can do that. Cool. So before I move on to Synapse, I've got a hypothetical stock market application that I've run here. So essentially, I've got this write optimized container for a bunch of stock readings. And this is just some seed data that I've created. So we've got the name of the stock, the open price, high price, low price, which index the stock resides on, how many trades were executed on that particular day, stuff like that. And in the past, say if I wanted to perform a query that gets all the stocks belonging to a particular index, I would have, if I was querying this container directly, this would have to be a cross-petition query. So in order to optimize that, I've got an Azure function that just essentially is listening to this stock container and then using the change feed to repetition my data. So there, instead of the ID of the document, I'm actually petitioning by the stock index. But now with Azure Synapse Analytics, this is a lot more straightforward. We don't have to create numerous containers just to satisfy different types of queries to try and optimize that. We can query our data directly within Azure Synapse Analytics. So what I'm going to do, I'm just going to run this to wake my Spark pool up. I set the auto time to 6 hours, so we should be fine. But while that's cooking, what I'm going to do, I've already set up my Cosmos DB as a link service, but I'll show you all how you can actually do that. So here within my Synapse Analytics workspace, I go to the Data tab here and just press plus. And here we're going to connect to an external data source. And once we can do that, we can see that we can actually connect to Cosmos DB accounts that have the Mongo API and the SQL API. My account's a SQL API, so I'm just going to pick that. And I'm going to give my service a name, Cosmos DB Conf. Bit of latency on my side, but that's okay. And we can connect to our Cosmos DB account either by providing a connection string or by using Key Vault. I'm just going to use my subscription. And then I can connect directly to my stock DB database. Test that connection. That should be all good. Sweet. And if I click create, that should create a new link service for me. So here I've actually connected to my Cosmos DB account through Azure Synapse Analytics. As you can see, I've already done that before. Now, if you take a look at these containers here, I've got 3 containers within my database that I've hooked up to Synapse Analytics. A very subtle difference here is with these containers have a little bar chart in their icon, and this is one that doesn't. So essentially what that bar chart indicates is that container has the analytical store enabled on it. So you can have different containers within your Cosmos DB account that have different, so you don't have to have all your containers with the analytical store enabled. Cool. So now I've got my containers linked up, I can actually read the data from that container as a data frame in Synapse Analytics. So here what I've done is I've just created this sample data frame. I'm reading in the format of Cosmos OLAP. So I'm defining my link service before and the container that I want to load, and I'm loading into this data frame. But as you can see, I've got the system generated properties as well as my data within this data frame. So what I want to do now, I just want to clean this up. So let's go NASDAQ DF, and I'm going to create a new data frame with just the name, number of trades, and just the index, just to keep it real simple, where DF index is equal to, hopefully I spelled NASDAQ correctly, Apologies to all my stock broker enthusiasts. Fantastic. Sweet. So I've created my data frame, and I'm just going to I've got the display. I just want to display 10 of them. I don't want all of the results. Come back to me. Is that right? Make sure that's okay. Yep. All right, sweet. So let that run. And I've got this new data frame. So I can remove all the system generated properties. All I've got is the name, number of trades, and index. And what we can do with Azure Synapse Analytics, we can actually, just checking for time, but we can actually write data that our data frames that we define in Synapse Analytics back to Cosmos DB if we need to. And this will be a snapshot of the data. If you're working with streaming data, you can actually write streaming data frames back to Cosmos DB containers as well. So what I'm going to do is, while that's creating in the background, I'm just going to go NASDAQ df dot, and I'm just going to do a bit of copy and paste. Make sure I get my link service back. So defining my link service here, make sure my container is created, sorry. Just write in NASDAQ. Cool. So once I start that job, I can actually manipulate the data using data frames in Synapse Analytics. And if I need to write that back into Cosmos DB, I can just perform this operation, and that should, that command is executed. Looks like it succeeded. So if I go back into my NASDAQ, there we go. So there's my optimized data model back into Cosmos DB, just as a real basic example. And if you're working with streaming data, you can write streaming data back into Cosmos DB. You can read streaming data from Cosmos DB if you've got data being written to your containers all the time. But that's just a real basic and straightforward example of how you can actually enable the analytical store on in your Cosmos DB containers, sync that up to Azure Synapse Analytics, and then work on the data using Synapse Analytics without affecting your transactional workloads. So let me just get back. I've got a couple more slides. Okay. So things to note at the time of speaking. Currently, it's only supported for the SQL and MongoDB APIs. My understanding is that the Cassandra API is still in a gated preview. I might be wrong on that, but there is support coming for Cassandra APIs. Currently, you're unable to enable the analytical store on existing containers in Cosmos DB, and hopefully that will change in the future. You can't disable the analytical store after you've created your container, so you're kind of stuck with it once you've enabled that. But the real powerful takeaway I think for all developers is that there's no impact on your transactional store in terms of RU expenditure and workloads. So hopefully in this session, you can see the real power of Azure Synapse Analytics and how that actually opens up a whole world of possibilities for us and for our machine learning engineers, data scientists, business analysts, whoever needs to perform analytics on that data. It opens up a whole new world for them. Cool. So thanks for watching. If you do have any, hello. If you do have any questions, I think hopefully we have questions in the chat, but you can also reach out to me. There's my Twitter handle. Cool. Thanks for having me.
That was great, Will. Thank you very much. There were a couple of questions in the chat. One was regarding hierarchical data and how deep that hierarchical data can go into the analytical store. I think it was to the gist.
So my understanding, I think in terms of nested properties, I think it's 200 properties is the limit. I think that's the limit in terms of different hierarchies for that nested data. So there's 200 nested properties, but I could be mistaken on that, or that might have changed.
Yep, great, thank you. The other, sorry, Will, the other question is in terms of where do you see before we had Synapse Link, we had to go through this whole manual ETL process. Now we have Synapse Link, so it removes that ETL process. Do you see any particular industries where Synapse Link is more valuable than other industries, or do you think it's across all industries in particular?
I think it's across all industries. If I can be a little bit biased and use some of my own experience, I used to work for a bank, and of course that's a particularly within New Zealand, where we currently don't have any data centers sitting in New Zealand, so it's a highly regulatory industry, and obviously we want to be able to perform analytics on our data no matter where that sits. And what this does is it really simplifies our ability to perform analytics on our data in Cosmos DB without having to incur a lot of costs, provisioning extra request units or creating new containers just to serve up particular queries. So that's kind of like the personal example that I always refer to, that this actually just essentially we can just use Cosmos DB as a purely write optimized store and then use Synapse Link to perform all of our queries if we're not performing any if we don't need to perform any complex queries within our applications, we can just offload that work to Azure Synapse Analytics.
So one other question that came up is how real time is this integration between the analytical store and the transactional store, and how have you seen the limits as you were building or you were testing this feature?
So the analytical store will sync with your data in the transactional store within that 5-minute time gap. So it's fairly real time, give or take, depending on what your definition of real time is. For some people that's seconds, but it happens automatically syncs within that 5-minute that time gap. Sorry, what's the second part of the question? What was that experience on limits?
Yeah, so was that deterrent for you, or did you were you able to perform your tasks the way needed to?
So using Azure Synapse Analytics, yes, we were able to query our data a lot more simpler. It was just much more straightforward because for our particular applications, our workload was quite spiky. So it would burst in with lots and lots of payments coming through our applications, and then sometimes it would be very, very quiet, very dormant. So without Synapse Linux, you've got you find yourself in this situation where you're provisioning extra throughput. You're trying to guesstimate how much throughput to actually provision in order to make sure that you don't get any rate limiting to your users. And with Synapse Link, that concern just for analytical requirements, it just goes out the window.
Sure. Hey, thank you very much. This is very cool. We will close this session with the resources and many details that people are asking about working with the analytical store, both on the notebook side in terms of where can they go for go-to resources. We'll put that on the chat and then share it with everyone. Thank you, Will. Appreciate. And this
Awesome.
was great.
Thanks for having me. Cheers.
Thanks, Will. So now I'm excited to have Martin Catherall, who's a data architect at MOQ Digital, speak today. Martin has a very interesting background. He recently completed his MBA, focuses on DevOps and the impact that has on the software development life cycle, but also has extensive experience in the relational database world in the FSI space. So it's not usual that you see someone that's got a bit of a dev background also has a bit of a data background as well. So Martin is also a regular speaker on SQL Saturday events, so both in Australia and New Zealand. So you might see him around the chaps doing that. And he's very enjoys sharing this information with the community. So today we're very lucky to have Martin tell us all about what Cosmos is for the SQL professional. Over to you, Martin.
Okay, thanks a lot for that, Ben. That was a great intro. So, yeah, I'm Martin from Brisbane, Australia. And just a bit of background about this this presentation. It's I don't know, in some ways it could be seen as fairly basic. Obviously the main audience is SQL Server developers or people who've got SQL Server experience and a kind of compare and contrast with the NoSQL world of Cosmos DB. But if you've got no experience in Cosmos or SQL, that's kind of fine as well. You probably pick up some details around how to get started in Cosmos. And even if you're a seasoned professional, there might be sort of tips and tricks in here that you have now got into the habit of, they're so common to you, you almost forgot them and you need to pass them on to other people. So I'm going to whiz through probably 10 or so, maybe comparison features, but really there's probably 3 big things that I'd like people to maybe take away from the session. First one is containers, and you might be tempted to compare containers and tables, the global nature of Cosmos DB, and you might be tempted to compare the global nature of Cosmos to things like availability groups and replication, and also the backup and restore features of Cosmos DB, and how maybe they compare to what is available in SQL Server. Because obviously doing backup and restore is a pretty fundamental task of a DBA and anyone within analytics. So what I propose to do is just whiz over to my next slide, introduce Cosmos DB, and it's a bit of a mouthful. Microsoft's multi-model, geo-redundant, planet-scale database. Sounds like introducing a heavyweight boxer, if you ever heard a referee introduce any of them. So we're going to come back to this slide, and I'm going to summarize. So we're not going to see any more slides for the rest of the presentation. But what we are going to see, we're going to jump straight into the portal, which I've got closed. No. Yep, going to jump straight into here, and we're going to look at the Azure portal. We're not going to set anything up. I've already got things set up. But what we are going to do, we're going to step through a few settings and kind of just going to talk about them, give a bit of an overview of how maybe that setting compares with the with SQL Server. Now, you probably heard Cosmos DB, born in the cloud. It's only available in the cloud. It's not like SQL Server where there was like an on-prem version for many, many years. And then it gradually made its way into the cloud. And from there, now we've got SQL database. We've got managed instance. You can even run it on a VM. There's lots of different ways to run SQL. But, if you want to get started with Cosmos, do you need to, have a cloud account? Do you need to set up an Azure subscription? Or is there another way to get started? And yes, there is. Cosmos has got an emulator. And what you can do is you can set that up. It's very similar to the portal. For example, I've got it on my screen now. And if we just go in, we can set up things like containers here. We're going to talk about containers quite a bit shortly, but containers is where we keep data. We've seen them, Will talked about them. I'm going to dive into detail a little bit more. And we can create databases in containers. One of the things you will notice about Cosmos, either in the portal or on here, there's a lot of different links and a lot of help available to get you started. For example, over here, we've got links to model data, cost and throughput calculations. So as a DBA, I used to do a lot of health checks. And as I was going around doing health checks, I eventually came a time when people would start asking me about Cosmos and what they were doing. And I didn't know anything about it really at that time. That was about, 3 or 4 years ago. And the answers I'd give were, I don't know anything about it, but based on my experience of SQL Server, maybe it works this way or that way or whatever. And thinking like that can actually eventually get you into a little bit of trouble. I mean, it may work out fine. You may just be may just be querying like one container. It's absolutely fine. But as you get into some of the more complex scenarios and you get more data in there, obviously you'll consume more resources, and that consumption will obviously result in a higher cost. And you might be doing things in Cosmos which are perfectly natural to you as a SQL Server professional, things like normalization and joining things, totally normal to you as a SQL dev, but contributing to a high cost in Cosmos. And then that's going to translate into, oh, Cosmos is really expensive. It doesn't really have to be that way. And lots of people think like that, and it ends up giving Cosmos a bit of a bad rap, when a little bit of thought and a little bit of forward planning can actually save you a great deal of money. But one of the big things I will say about designing for Cosmos is it's probably going to be really important, more important than probably in SQL, although it's still important in SQL, to know what sort of workload you're going to be dealing with, what sort of queries are going to be coming in, and how you're going to be answering them, and how many there are, because that's going to have a really big bearing on the cost of this in the long run. But there are some really cheap ways to get started. So anyway, that's the emulator. So we're now in Cosmos DB. One of the big differences straight away is you'll notice that this is a Cosmos DB. It's called an account. So in SQL Server, we've got at the top level, we've got our instance, and then obviously we've got our databases and stored procedures, and the model that we all probably know and love in SQL Server. Whereas that's a little bit different in Cosmos DB. At the top, we've got an account. Underneath that, we do have databases. And then underneath the databases, we've got containers, where most of you would be used to seeing tables. So there's a loose analogy between the two of those, but don't think about them as a one-to-one match, certainly. So let's go in and just like create something. We won't actually be sitting here waiting for creations to finish. I've got a few already made. So we'll just enter a name. And okay, so the first big difference between like SQL and Cosmos really is the models that are available, or the APIs. So I've recently heard people refer to SQL Server as having multiple models because it's got things like JSON and XML. I'd never really thought of it that way. But in Cosmos, there are actually 5 different models. And you might loosely think them as database models. We're just going to concentrate in this presentation on the core SQL API, although the other two for Mongo and Cassandra will help you to put data into those models, and it should work exactly as it did for in a Mongo or a Cassandra. Table storage, very similar to the key value pairs that we've got in our storage accounts, and we've also got a Gremlin API. So we're just going to concentrate at the minute on the core SQL. And you might think just by the name, that's exactly the same as SQL Server. Now, there are similarities, but there are also big differences. So I just set this up in the West US, and we can either provision throughput or we can go serverless. If we go serverless, we just literally pay as we go. Might be a good model in some scenarios, might not be. But what sometimes catches people out is this here, pre-provisioning in advance. So here we can see I've got 400 RUs, that's resource units, and I can service queries with a combined total of 400 RUs, or 400 resource units. So how does that work? So let's say I provisioned 400 RUs per second, and let's say I've got a query that, for argument's sake, costs 10 RUs. So I can service 40 of those and every second, because that will take me up to my 400 RU limit. If I get 50 that come in that second, well, what happens? well, they won't be answered in that second. They might be queued. And if they eventually get queued too long, you will receive you'll be throttled, as you say, resource limited, or rate limited is something that you might hear quite often. And that will give you an error. And if you program something in your API, you're probably best wanting to retry. So have retry logic. And there's actually places where you can go and see what errors or not your queries have actually given you. So be very careful about that and monitor your workload very closely. So knowing what it's going to do initially is a great start, but monitoring it and seeing if you've got things coming in that are going to take you over your limits, because this is where it can get quite expensive. And so you'll also want to write your queries in a way that reduce the amount of resource units that we'll use. And we'll look at some examples of how you can do that shortly. Now, it's actually a free tier. I've actually exhausted mine in other ones, but you can actually go for a free tier here if you want. So that might be a good way to graduate from the emulator and things like that into like the free tier here. Then we've got, we can choose between our production and our non-production. Now, a lot of these options used to be on the same page, but if you notice here, I've chosen non-production. If I flick over to global distribution, that's going to set me up with no geo-redundancy and no multi-region rights. If I change that to production and flick back over again, that's now set me up with geo-redundancy and multi-region rights. So global geo-redundancy, as it says, if you provision in, say, West US, as I've done here at the moment, I can have another Cosmos in the region pair. Interestingly enough, if I change this over to another region, let's say Australia, when I find it, Australia East, and look again at the global, we can see now we've got availability zones here. So we didn't have that when we chose the West US region. So there are different options available for different regions. Now, even if we were to choose no geo-redundancy, behind the covers, there's 3 or 4 different replicas almost of your database that you can use there. So that's geo-redundancy. Backup policy is probably something that maybe as a database professional might take you a bit by surprise. So, because backups can be done on a timed basis almost. So here we've got the backup interval of 240 minutes, which is every 4 hours, and they're going to be retained over 8 hours. So these backups are only being retained. We're only retaining 2 of them. So we're doing backups every 4 hours, but we're only retaining them for an 8-hour period. So that's a little bit different than just setting them up yourself. So something that might take a few DBAs by surprise. Now, there is a backup policy that's recently come in to do continuous backups. And that's there at the moment. So we can change these around 2 days and things like that. You can experiment with them. We've got local redundancy. Like I say, if you've got local redundancy, you do have multiple copies behind the scenes. We've got encryption, similar to we got everywhere else. TDE, similar sort of thing, and all that. But let's can out of there. We don't need that anymore. Can't actually lost. I just go back to Cosmos DB. Sorry, I lost my close button there for a while. And we'll go into one that I provisioned earlier, so we don't have to mess around with things. And we're going to talk about globally distributing data. So here we've got our West US. I've just set this up in the West US with a region pair at the moment. I'll just click back on there. And if we want other regions, we can just click around. We can add them. And that you might say, oh, well, SQL Server can do that too. But all these different regions can be writable. in SQL Server with availability groups, like we've literally just got one write replica distributing data to the other read replicas anywhere around the world if we wanted to. But with Cosmos, this isn't the case. And also the latency is quite low. There's actually an SLA around the latency to do with like sort of 10 milliseconds and that type of thing. So you might have a question around that. Well, how does that affect the data that's being transferred between different regions? And whereas in SQL Server, we've got like recovery models, and that would affect how your database passed off transactions to other replicas around the world. In Cosmos DB, we've got something called consistency models, and there's 5 of them. And I'll go from the very outside to what we call eventual consistency. You might be familiar with this with things like social media. You know, if you enter data in, say, Australia, you know, does it really matter if your friend in America or Europe or wherever sees that update straight away? So long as they see it relatively quickly, there's no big deal. So the thing about eventual consistency is like it's not really going to honor anything. Your writes that you put into the local database will eventually make their way to other replicas, but you've got no kind of guarantee that in what order that they will do that. But you still have many, many replicas around the world to do that. On the other side of that, we've got something that DBAs would probably be way more familiar with: strong consistency. You know, when you put something into the database, you guaranteed to be consistent on all replicas before you can see it. Now that's going to bring up a big problem if you've got multiple replicas around the world, because you know you might enter something in Australia and then it's going to have to harden in, say, America or Japan or whatever it is before everyone else can see it. So Microsoft's obviously aware that there's two ends to that, eventual and strong. So they brought in something called session consistency, which is in the middle, and gave us basically 5 consistency models. Now, I have a problem remembering these, so I borrowed a blog post from my friend Will, who was on the presentation a minute ago. And session consistency, so clients that are outside the session are doing writes that will eventually be consistent. So this is the default. And between the default and the eventual, and the default and the strong, we've got 2 other consistency models. So going towards the eventual end, we've got something called consistent prefix. And I like the way Will's kind of summed this up in really a sentence. Reads in consistent prefix are guaranteed to never see writes that are out of order. If we go the other way, to the bounded staleness, which is towards a strong consistency, we can configure bounded staleness by either the number of versions, so your data actually gets versioned as it goes in, of the item, or by the time interval. So bounded staleness is kind of similar to strong, but you've got a window where you might see something that's not quite hardened in other places around the world. So that's a real big difference between SQL Server. It does, however, you know, bring up some real interesting opportunities. You know, if you've got a say a data center in Australia and you're a shop in Australia, you could have all your clients there go into the Australian database. Then you might decide to open something up in America. Same sort of thing. You get all your American clients going to a replica that's in America. So they're both writing, Australian clients write to the Australian replica, American clients write to the American one. Those 2 Cosmos databases are syncing in the background. Now, as a business case there, you would expect Australian people never to clash with American people and the 2 just merge, but not problematically. However, what happens if there is a problem? What happens if someone enters data in Australia and then they enter it in America at the same time and there's a clash? It's a pretty common question. Well, Cosmos DB has the notion of last writer wins. That's by default. So the person who entered it most recently, the last writer, will win the transaction. However, you don't have to accept that. You can write functions to take care of that logic all by yourself and basically create your own logic. But let's actually look at now. Let's go back over and we'll look at some stored procedures. So if you go to the Data Explorer, have I put stored procedures in here? I put stored procedures in one of these. It looks like it wasn't that one. So, but I can create a container. Now I have to give it a name. We've seen before that I could place my RUs on the account. I can also place them on a database, or I can place them at the container level. Here I'm going to place them at the container level. Give my container an ID. I'll just call it ID. And a very important feature of Cosmos is a partition key. Now, this is not to be really confused with the partitions in SQL Server. They are kind of similar. If we are, for example, partitioning our table by, say, state, we're getting people to enter their address, and we're partitioning by state. But we've got perfect control in SQL Server about what goes to what basically space on disk. We don't have that with Cosmos DB. We just think about these partitions as being logical. And what we want to avoid is hot partitions. So, for example, in Australia, we've got, say, 7 or 8 different states. If I partition by state, and I've got a lot of people in, say, Victoria, which is one of our states, hitting that a lot, I'm going to get a hot partition. And that's probably not a great thing. So maybe we can go a bit more granular, and maybe we can partition, say, by postcode. So I'm still getting a lot of people in different postcodes throughout Victoria, but generally speaking, the data is more evenly distributed around Cosmos DB. So it's a pretty key concept in Cosmos to place in our partition key. So think about that really well. And one of the things that might surprise you, just to round off, is containers. Now, in SQL, you'll think nothing of joining 2 tables, whereas in Cosmos, joining 2 containers can be an expensive query. You want to avoid that as much as you can. So you're probably thinking, well, joining's pretty fundamental. But you've got to adopt kind of a different mindset, really. Duplicating data in a NoSQL world is a lot more acceptable than duplicating data in a transactional world or a relational database. So you might duplicate data in 2 containers, and then you've only got to query 1 container. Will result in a less costly query and won't cost you so many RUs, and that will translate directly into dollars and cents. So partition key. So if you don't put a partition key in, that's another. Well, if you put in the wrong partition key, or you run a query that doesn't have a where clause that references your partition keys, your query has to fan out, and that's another expense as well. So 2 tips there to really make your database more cost effective. Try to avoid joins. Denormalization is kind of fine. And try and pick a good partition key, and always use a where clause in your queries that has your partition key in it. And that way you won't fan out across the various partitions, and your query won't be so costly. And keeping those 2 things in mind can result in some fantastic savings for you. So I'll just flick over to the presentation to summarize. We are nearly out of time, but born in the cloud, we've got the emulator we can use. We've got T-SQL versus JSON. Cosmos uses JSON, not T-SQL. The language, the subscriptions, the account, the database, the containers, rather than the instance, and the database and the store procedures. Multi-models and APIs we have. Denormalizing and denormalizing, not such a big deal in the NoSQL world. Backups and restores. Plan these well, because if you need to do a restore, you actually have to get on the phone to Microsoft. Recovery models versus consistency models. Archiving, which Will touched on previously with the time to live, so I didn't spend much time on that. And finally, last writer wins. And so that was actually the last writer. And now I will hand back over to Ben and Serena, and wonder, are there any questions that have come in and you'd like me to answer?
Great. Thank you very much, Martin. That was very insightful. I was going to ask you just regarding, from moving from the relational world to the Cosmos world, how have you found, or what sort of types of questions are you getting people asking who are SQL devs, and what sort of questions are they asking you about, moving to a NoSQL world, and what sort of mistakes do you think that a traditional relational dev would do?
Yeah. It's an interesting one. People tend to look at the NoSQL stuff and just go, oh, it's a database, and there's a database here, and the two things are the same, with maybe an obvious difference to start off with. One uses T-SQL, the other uses JSON. And then they'll think, oh, JSON's really flexible. So I've got all the benefits of SQL Server, and now I've got the benefit on top of using JSON. And they always tend to take it back to, almost use their relational database knowledge as a baseline. So they think Cosmos will work exactly the same with this additional feature on top. For example, flexibility of JSON, the multi-region writes, and joining containers is a fundamental thing to do. Whereas like in SQL Server, joining tables, no problem. Joining containers in Cosmos, probably may run into a bit of trouble there down the line. So I just think it's not really planning that well. So what I'd advise is to really dig in, do the groundwork. There's a lot of similar presentations that MVPs have done out there similar to this one, and they'll touch on different things. Other people will go into partitioning more deeply. But generally speaking, I would avoid taking your relational database knowledge and just thinking Cosmos offers certain features on top of that. That would be not a great way to think.
Yeah, so it's not like you take up the relational mindset and basically creating a container for each table or something to that effect.
Yeah.
But really focus on the data modeling side and change your way of thinking around not worrying about duplicating data and things like that.
I think that is well summed up. It is about mindset. It's also about opportunities. There's different opportunities you get with the NoSQL world. And if you're still thinking like a relational person, you're kind of limiting yourself with those possibilities. So basically, we all know about data. There's obviously a lot of crossover. We can take our data knowledge from one place to another, regardless of whether it's Cosmos DB or Synapse or wherever. Data knowledge holds true wherever we are. Just digging into those, what I'd say, fundamentals. For example, the time to live, which Will touched on in the previous presentation, is a great feature that DBAs would love to have in SQL Server. Save as archiving. When your record's 5 years old or whatever, it gets archived or deleted. So there's like I say, different opportunities in NoSQL than maybe there are in the relational world.
Yeah.
Hey, Martin, thank you. Thank you so much for your time and for the session. We'll now move on to the next one. Right. Before we do that, I just wanted to let the audiences also know, do not forget our Twitter handle, which is #CosmosDBConf. Do tweet in about Martin's session, previous sessions, any questions you might have. We are also answering your questions on the chat right now. So feel free to keep putting on more. We are excited to be here and we want you to get your best, right? With that being said, let's the third session for the Asia time zone, which is actually the eighth session of the Cosmos DB Conf here, is on GraphQL over Cosmos DB. And where do you start? One of the hot topics, as we see, and we've had a lot of feedback from the customers that this is exciting. Presenting to you, Aaron Powell. He's a developer advocate, spent about over 15 years web development, so familiar with Ajax, JavaScript frameworks. He's tinkering on trying something new. You've seen him as part of Microsoft's developer advocate, going around and doing sessions. Very excited to have you here, Aaron, and take it away. Looking forward to your session.
Thanks for having me on. So, welcome everyone to our session here today at Cosmos DB conference about GraphQL and Cosmos DB and how we can get started. So this session is going to be a lot of introduction around how to bring these technologies together. And it's a good segue, I guess, from the session we just had, which was talking about how we can model data, particularly thinking that using that SQL API in Cosmos. So I'm glad that we've had that covered off so that we can look at how we can then do some application with that. As said, my name's Aaron Powell and I'm part of the Cloud Advocates team here at Microsoft. If you want to get in touch with me after the session, ask any questions that I don't get a chance to follow up with before we wrap up today, feel free to tweet at me or send me an email or anything like that. I'm always happy to do my best to answer questions where I can or direct you to someone who might have some better insights into how to answer said questions. But you're not here to hear about me and what I've done and all my career and things like that. You're here to learn about GraphQL and Cosmos DB. But first off, let's talk a bit about what GraphQL is to make sure that we're all understanding the role that it could play and why we're talking about it at a Cosmos DB conference. So GraphQL is a query language designed for doing APIs, whether they're web APIs, so a web application talking to a server, mobile, console applications, or anything in between. We can use it as a query language for any sort of application design. It was originally created by Facebook. Facebook created it to solve a problem that they had around how the client was requesting data in the Facebook newsfeed. So if you think about the way the Facebook newsfeed works, it has a lot of information that's appearing there, and it changes the way that that works depending on the context that you're looking at. So with traditional API designs, whether it's REST or custom-made APIs for a particular service endpoint, you end up having to put a lot of the responsibility of the API design into the server, and the client is just kind of left to consume the way the API works. GraphQL, on the other hand, flips that so that your control is then inside of the client that's requesting. So the client is the one that has the power to say how much data it wants of the available objects that it's querying against. So this makes it a lot more appealing for certain scenarios in which you're going to be building applications. Now, it might not be right for every application, but there's definitely scenarios where it can work well for. Another thing that GraphQL brings in that is quite interesting and is different to a lot of other API design models is the idea of real-time through its subscription notion. So in GraphQL, if you wanted to do something in a real time over like WebSockets, for example, you can use the subscriptions feature of the GraphQL language design that allows you to then connect to something that is happening on your GraphQL server and be notified without having to do something like long polling or any other HTTP approaches to doing kind of real-time approaches over HTTP. It's designed to work with WebSockets. So this can be definite advantages in some scenarios, again, particularly if you're working with an application that has that notion of needing to get real-time feedback from the server that it's working with. So for the application that we're going to build out today, or that we're going to have a look at in a little bit, I'm thinking about this idea of a trivia application. So like many of you, I've been stuck at home and my primary form of social engagement has been over video conferencing platforms, and I've been playing trivia games with my friends. So I decided, well, let's see if I can actually build one or at least model that out. So we have our game object here, and it's going to have things like an ID, the state of the game, like are we currently playing the game, or are we waiting for people to join? Is the game completed? How the players connected to the game, questions and answers, all that sort of stuff. We then have some relationships to other data models that we've got within inside of our Cosmos store. So we have our player, which has got a many-to-many relationship back to our quiz, because one player can play multiple games and one game could have multiple players. And we might want to be able to go back from a player to a game or from a game to a player. We then have questions. Again, they've got some more information on it. And so we can start seeing how this data model is starting to come together. From a GraphQL standpoint, we would then interrogate this by defining a GraphQL schema that says that we're going to have a couple of ways that you can enter our data model. You can request a single game by its ID, and that'll give you back the game object. You can request all the games, and that will give you back an array of all game objects that exist. This might be maybe more of an admin feature, not just everyone can grab access to every bit of data in the system. And then finally, we can get back all the answers that a player has given for a particular game. To then query against GraphQL, we will write up a query such as I've got here on the bottom of the slides, where we go to, we're querying against the game, providing with an ID. But as we saw on the slides before, game had things like state, players, questions, and answers. But in this case, maybe I only want to show who's currently playing the game, or the current players that have joined the game, as we haven't actually entered the game and started off asking questions. So in this case, I'm only asking for the game, its ID, and then the name of all the joined players. So this is where GraphQL is different to approaches such as REST. I no longer am getting back all of this other details that I don't need at this point in time. I'm just getting back what I need right now. So how are we going to start building out this application to work, or this server implementation with GraphQL? Well, we're going to have three primary layers. We're going to have somewhere to store data, some infrastructure to run it on, and then a server that implements the GraphQL spec. So for storage, you're probably not surprised for me to say that we're going to be using Cosmos DB. Kind of makes sense. We're at the Cosmos DB conference, so we probably should use Cosmos there. We could use it with its its Mongo API. We could use it with the SQL API. We could use it with any of the other communication formats. I'm going to use SQL in the demo that we get to a little bit, but that's kind of immaterial to how you would be communicating. You communicate with it the way that is going to be best working for the sorts of queries that you need to build from your schema that you've got in GraphQL. Now, Cosmos actually works really well, in my opinion, for working with GraphQL because it has a schemaless notion. So while it does have some pseudo-relationship approaches by the way that we can model our data and the way that we can work with it, particularly if you're working with the SQL API, it is still a schemaless database. And while GraphQL is a strongly typed schema, it is really much designed around being used in a schemaless fashion to talk to our databases. So I think they're a great fit to work together. So that's Cosmos DB sorted, but what about the infrastructure we're going to run our server on? I tend to go down the route of using Azure Functions. I like it because I like the scalability I can get out of Azure Functions. It means I don't have to worry about infrastructure in any way, shape, or form. And I tend to either be writing in .NET or JavaScript, so it fits again quite nicely with that because I can run both of those options there. And especially if I'm going down the .NET route and building a GraphQL endpoint, I don't even have to worry about establishing connections to Cosmos DB. I can have that entirely managed by the Azure Functions runtime and get that document client back and get access to the SDK. So I don't even have to think about connection pooling and connection management inside of my GraphQL server. But there is one drawback if we're going down the Azure Functions route, and is that I can't do real time with subscriptions. Azure Functions only allows me to do HTTP triggers inside of my GraphQL server. So in that case, I'm probably going to want to go down the route of Azure App Service. Azure App Service is a way that I can run anything in a platform as a service model or a PaaS model. So whether it's a .NET application, Node application, Python, PHP, Java, etc., I can run those quite easily with inside of App Service. And because I'm running then much closer to the web server itself and managing scale out and things like that, I have more visibility over the kinds of resources I've got deployed, and that I can even do things like WebSockets. So I can have that real-time subscription notion. And these are two options that I would look at first. before going down the route of like rolling my own virtual machine or going into a containers approach, because I think both of them can be used really effectively for building a GraphQL endpoint and then communicating through to our downstream services. So we've got Azure, Cosmos DB working with app service or functions. What about the serverless implementation? So GraphQL is just a spec that you have to implement in some form of a server. In this case, I have two server models that I tend to go with. The first is Apollo. Apollo is an open source project written by a company called Apollo, unsurprisingly, and it's an implementation of a GraphQL server in JavaScript. It's actually written in TypeScript, but that means that we're running in JavaScript anyway. I like it because it's got bindings into Azure Functions, so I can easily deploy an Apollo server into Azure Functions without having to worry about how do I do the bindings with the HTTP trigger, how do I do a response appropriately, so on and so forth. But if I did need to do subscriptions or I wanted to deploy that as a Node server, it's also got bindings with Express, Core, and other popular Node.js web server frameworks. If I'm going down the route of .NET, I would go with Hot Chocolate from Chili Cream. Bizarre name, so it can be a little bit confusing to realize that this is actually a GraphQL server, but Hot Chocolate is going to be really approachable for someone that is very familiar with the .NET and particularly a C# programmatic model. Instead of going down the schema first and designing a schema file, where we'll see in a moment that you often see, particularly in JavaScript applications, it uses a type safe and a type first approach, similarly to the way that you would do with like Entity Framework, if you're working with Entity Framework over a database as the storage model. So if that's the kind of programmatic model that you're used to with building data-centered applications, then Hot Chocolate is probably a good approach for you in that regards. Right. So we've got Apollo or Hot Chocolate. That's going to be our server implementation that we're going to run. We're going to put this into either an app service or an Azure function, and we're going to connect this through to Cosmos DB. So let's now jump over, it's probably enough slides for the time being, and actually see how we can go about building one of these servers out. I have a pre-built application here that we're going to go through a number of different steps because, well, for the sake of time, I don't want to spend it all in just trying to build out one single part of the application. But what we've got is an Azure function that is going to then be turned into a GraphQL endpoint. So I've got the starting of this already. If we open up my package.json file here, we'll see that I have the Apollo server Azure Functions node module installed so that I can build this as a GraphQL server running Apollo and deploy to Azure Functions. Inside of index.ts, so this is the entry point for my Azure Functions, I'm importing the Apollo server and a couple of other tools so I can load my schema file. And then I'm also bringing in some resolvers, which are the things that are going to handle the queries that happen. And then this is being turned into an Apollo server, which is then served out by my Azure function. If we have a look at our schema, we'll see that the types that I had modeled in the slide in my crude drawings, modeled as GraphQL types. I have question, which has IDs, correct answers, question, the full array of answers, the game state as an enum instead of just as loose strings, players, etc. And if we scroll down towards the bottom, we'll see that we have the query as well. So the query is then where I have that entry point. So how do I get back a single game? How do I get back all games? How do I get back the answers that a player has made and submitted for a particular game? So this is what our starting point for our application is going to be. And next, let's have a look at how we can go about building those the resolvers to start talking with Cosmos DB. So I will move forward in time by going to a different set of Git commits. And inside of this, I've started modeling out my data model inside of my application. So I have this new folder inside of my Azure function called data/cosmos. The reason I've got it Cosmos and in memory is because this application has the ability to be run just as an entirely in-memory data structure or as a Cosmos DB one. Obviously, we're interested in the Cosmos stuff today. But I've modeled out some types that I would then use with Cosmos. So I have this base model type, which is containing an ID and what type of model are we storing. So this is then going to be my partition key in the Cosmos containers that I'm working with. I then have a question model, which has those fields that are coming back from my Cosmos database. So question, category, incorrect answers, correct answers, etc. These don't map exactly to what my schema says. My schema is just, it doesn't have the concept of incorrect answers and correct answers. It just has the concept of answers because the user shouldn't see that kind of domain modeling, we want that kind of rolled up for them. But that sort of stuff is what I can have then inside of my database that I expose slightly differently through through GraphQL. And then we've got a couple of other models that are implemented here. And then I have some data stores. So the data stores are how I'm getting Apollo to talk to my Cosmos backend. So I have game, user, and question. So these data sources are a pattern that Apollo provides, is the data source pattern. And then I just put in the members of that makes sense for the kinds of interaction that I want to do. We'll jump into the resolvers.ts file next, because this is where we're going to start building out the resolvers that will be talking to those data sources and then getting the data out of our Cosmos DB backend. Actually, but before we do that, let's have a look at how we've connected to Cosmos. So for this, I'm using, there we go, let's just collapse that a little bit further so that we can see a bit more of the code on screen. I'm using the Cosmos SDK from Microsoft. So I get back a Cosmos client, and then establishing a connection using the connection string that's been passed in, and then creating these new Cosmos user data source, question data source, and game data source. Let's jump into, say, the question data source and have a look at how that's implemented. I've brought in another node package. So again, this is all built on open source technology. So I brought in a package which is Apollo data source Cosmos DB. This is written by another person at Microsoft that is a wrapper around the Apollo's approach to doing data access that then talks directly through to Cosmos DB. So it provides me with a bunch of APIs such as query by many, which can take a SQL spec query or a string. It understands parameters that can be passed in. I also have other methods on this for doing updates, creates, getting single items, and so on and so forth. But the reason that I'm using this is not just because it gives me some convenient wrappers around the Cosmos SDK, but because it's got built-in caching. So this works with a caching model that is provided by Apollo so that I can pass in a TTL, or a time to live, when I'm doing a query so that I'm caching the data that's happening in there and not having to worry about how long that's been available for or when I'm going to have to get that back. I get caching kind of built in nicely, and I can control the cache level I want on the different queries that I'm performing inside of my Apollo, inside of my data source that my GraphQL application is using. And let's jump over to the final implementation of the application, and we'll bring up that resolvers.ts file that I was talking about. This is, well, it's not doing anything particularly exciting because all it's doing is it's talking to those data sources. So as far as GraphQL is concerned, it's just talking to something that's managing our Cosmos access. And that's really what we get out of by having this level of abstraction through data sources in Apollo. We get this nice simple API. So when a user has requested a single game, I've just said, well, here's a method that will tell you, will get you a game. This is returning a promise of the game model, which is then mapped through into our GraphQL result. I've got this already up and running inside of my browser. So this is the GraphQL playground. So I just launched this from my VS Code instance, and the GraphQL playground is up and running. I've got a query here that allows me to get back all of the games in the application. All the games in my my Cosmos backend. So let's kick that off, and we'll notice that I'm pulling back the ID and the state. But I could also be saying, well, I also want players, and then from players I want name, so on and so forth. So GraphQL allows me to build that out, and because the way that we've designed our underlying data model is a schemaless notion inside of Cosmos DB, I should be able to map that pretty well. But you don't want to map your queries one-to-one between what someone could do in the browser and what someone could do, the actual SQL query that you're going to perform. So that's something that we need to think about a little bit differently in the way that we're working. But we'll execute this query, and we'll come back over because I've popped in a breakpoint here, and we'll see that we've ended up here, broken on the resolver for games, which is the query operation that we've just performed in the browser. And then this will come through to get games inside of my game data source, which is then going to perform a Cosmos query, which is against my partition key. So this is just getting everything back. We'll just hit F5, run that through to completion. And there we go. We've got back all of our data. I can perform a write operation. So in this case, it's called a mutation in GraphQL, which is going to create a game. And if we hit execute on that, that's going to add a new game, grab its ID, And then we could create a new query. If we go query and we say game ID of this, BIHN, yep. And then we'll get back the state. And if we go players, name, there should be no players in the game because there isn't anyone that's there. We'll come back and we'll add, how about we call a mutation, which is going to add the player to the game. We'll execute that. And it looks like I have, I should have probably tested my application a bit beforehand because I've got a runtime error. And this is what happens when you go off script in your own demos. Lesson be learned, stick to your own script. We'll move on from the error. Trust me, it does actually work. And I'm sure if I spent a few more minutes reading the error message, I'd have a better idea of what actually went wrong. But I was just going to finalize by showing how we can do that, that create and add user to the game. So we'll come down to that mutation, which is add player to game, down here from line 74. So what I'm doing here is I'm going out to the user data source, creating the user, then getting the game, and then updating them. Now, I could be doing this using the Cosmos DB change feed if that was a preferred model to doing it. But I've just felt that it was nice to wrap it up and make it very clear inside of this one GraphQL resolver that this is what's going to happen, mostly because we're going to be returning back the user. I'm doing it all here. But it's definitely the sort of thing that you would look at and go, maybe adding a player to a game, do they need to, like, should this be talking to the game object itself? I'm not sure. Or is that something that's better handled by a change feed like management process in the background? But that's something that you decide based off of the needs of the application that you're building. We're just about out of time today, so we'll just quickly wrap up by just a quick recap of what we've done and what we've talked about today. We've had a look at how we can build a GraphQL server using Apollo, or if you wanted to go down the .NET route, you could check out something like Hot Chocolate. We could deploy this into an app service or an Azure Functions. In this case, this was one running on top of Azure Functions. And obviously we're storing our data in Cosmos DB because it wouldn't make sense to be at a Cosmos DB conference and not be showing you Cosmos DB as the storage engine. I'd probably be doing a disservice if I was looking just straight at SQL Server or something like that. If you want to check out some of the projects that I talked about today, Apollo GraphQL and Hot Chocolate, their links are on the screen, or I've provided QR codes if you want to scan those as an easy way to get access to them, because I know that you can't reach out and click the links in my slide deck here. If you want to have a look at the code that I was showing there in those little demos, I created a workshop on building a GraphQL and TypeScript application, and you'll find that on my GitHub at github.com/aaronpowell/GraphQL TypeScript workshop, or follow the QR code. And that goes through a whole bunch of different steps to take you from I've never built a GraphQL server to having a server and a client working together in TypeScript in a type-safe model, working either against Cosmos DB or against a in-memory database. And I've also done a blog series on how to get started with GraphQL on Azure that looks at how we can deploy .NET or JavaScript GraphQL servers, how we can connect them up with Cosmos DB, and how we can do some real-time work with subscriptions. But as I said, we're coming to the end of the time that I had today. I hope that's been interesting. I hope you've learned a few things about how easy it is to get started with GraphQL on Cosmos DB and have that running with inside of Azure. As I said, if you got any questions that I don't get a chance to answer today, do reach out on social media or via email, and I'm happy to do my best to answer them. But again, thanks for having me, and hope you enjoyed the rest of the conference.
Hey.
And the crowd goes wild.
I love it. Love it. Thank you so much for your session. It's great. Couple of feedback questions just here and there that we're hearing. One thing is GraphQL as a query layer over Cosmos DB. What are the trade-offs in actually from the Cosmos database's performance, maybe latency, speed, or even RUs? What were your give and take of actually using the wrapper of GraphQL as a query language into Cosmos database? And additionally, you did choose a partition key, which you showed in your code. So there's probably also a question as to how did you come up with that?
Yeah. So from the standpoint of like how do you optimize for performance and for RU utilization with Cosmos when building a GraphQL solution, it's for me, I look at it the very same as if I was building any other kind of application. What is the sort of data structures that I need to store for the kinds of queries that someone wants to access? Now, this does mean it's a little bit more challenging because the client is the one that is controlling how much data they request at any given time. So you need to think about what are some of the common scenarios and give people those entry points into where they're going. Rather than just giving them the type schema and saying, well, if you want you can always just get back all of the games or all of the users, things like that. You give them kind of constrained entry points because that can help you predefine the queries that you're working with. I'd also be looking at how to leverage things like user-defined functions and have those as the things that are actually doing a lot of the heavy lifting with inside of my Cosmos queries, rather than just trying to write a generic kind of catch-all query to cover everything. I'd also look at how we can do data denormalization so that we can have a data object that stores as much of the data as possible inside of itself. So where I had the game object inside of my Cosmos DB, it also then embeds the user and the questions and their answers, rather than having them in separate entities inside of a collection, because that means that I can query for one top level object and then select out the fields that I need with inside of it, rather than having to query across multiple different objects. Then in terms of partition key usage and how do I work out what would be the partition key, I'll commonly have all the top level objects will have some sort of a field that indicates its type, for lack of a better descriptor. So in this demo application that I have, it's called model type, but it would be whatever it is to indicate that this item you're requesting is a game versus a user versus a question, and use that as the initial refinement of the query based off of partition key, so that we know that we're starting with a game and then we're selecting the subfields off of that. Now, I didn't do optimization so that if you are only wanting just the name of a player, we only select that one out. We would select all the fields that are on a player, but that's mostly because I didn't want to go to the depth of how do you dynamically create Cosmos queries that have field selection based off of the input that someone has provided.
The other one that came up is indexing. How does that work with GraphQL versus do you need to have some sort of index optimization at the GraphQL layer, or are you leaning back to Cosmos DB for doing the heavy lifting?
No, I would definitely be leaning on Cosmos DB to do the heavy lifting from an indexing standpoint. So if I know that there are like the children objects that I would be likely wanting to query across, or that I've got other fields that are on my top level models that I would like to query across, and that are places of initial refinement beyond the partition key, I would definitely index for those. It does mean that you, with GraphQL, because the client is the one that's in control, you do have a little bit less insights into how someone wants to use your GraphQL endpoints and what that means for the kinds of queries you have to predefine. So you want to have some sort of an analysis system that's monitoring those queries, looking at what someone's doing and trying to identify where you have hotspots in your RU usage, and then do you need to index on them? Do you need to redefine the query that it's got? Do you need to break them out into separate partition keys? Things like that. So rather than optimizing first, because it's really hard to optimize for the way someone consumes GraphQL, I definitely wait till I start seeing some insights from the way queries are being used.
Sounds good. Thank you. The last one quickly was on in-memory, where you had stored things in memory. How does GraphQL relate to scale out as opposed to in-memory for your apps?
So if you're going to store data in memory, it's going to scale out just as well as any other system that's storing in memory. The more memory you throw at the machine, the bigger it's going to get. The in-memory example that I've got there is just so that you can run the demo application entirely offline. I wouldn't be deploying a production application in memory. I'd be using, the only time I'd be using in memory is for some level of cache, unless I was able to go to like a Redis or something like that as a cache model.
Thank you. Thank you very much for your session. We are on time, so it's now time for the next one. So thank you, Aaron.
Thanks for having me.
Great. So I think the next session, Shiner, was quite poignant when we were just talking about data modeling and partition keys. So I think when the next one is regarding data modeling, we're going to play a little bit of a video, giving you a bit of an insight into that. So I think that's our next play before our next talk.
Let's go check out the video.
Azure Cosmos DB enables incredible speeds, provided you choose the data model that best supports how you use your application. Data modeling is the process by which you establish patterns and rules for storing data across documents and containers, determining how data is accessed. Choosing the right data model for your workload results in better performance and faster speeds, especially as your database grows. While there are many nuances to data modeling, every project starts with the same question: whether to embed or reference. Embedding, also known as denormalizing, allows you to combine related entities into a single document. When used with read-heavy applications, results come in fast and ready to serve, no joins required. Embedding often leads to data duplication. With Azure Cosmos DB, duplications aren't a problem. The Azure Cosmos DB change feed helps maintain referential integrity across containers. Embedding falls short, however, when there's no practical limit to how much data will be stored and you reach the maximum size for a single document. It's also not ideal for write-heavy applications because it can lead to bottlenecked requests. In those cases, it's better to use referencing or normalizing like you would for a relational database. By creating unique entities that reference one another, you can break up write requests and break down large documents to speed up your application. Enable top speeds and seamless experiences at any scale with Azure Cosmos DB by implementing the right data model for your application from the start.
So I hope that little video gave you a very quick highlight of sort of embedding and how you to do some data modeling at a very high level. And obviously there's further documentation you can see to dig deeper into those topics. The next speaker we have is Kaliasyan, a senior engineering architect from Adobe, working on the Adobe Experience platform that I'm sure most people have heard of. He does a lot of work around the real-time scoring and personalization of that platform, and has a strong experience across the different technology stacks around Hadoop, big data technology, Spark, Linux, Python. So very strong background in that whole analytical space and around the modeling and real-time scoring. So I'd like to hand over for the next 30 minutes to Kaliasyan to talk about real-time scoring to improve personalization with Adobe Experience Platform.
Hello everyone. Marina?
Hi everyone, this is Marina. I also work with Kalai in Adobe. I am a data scientist, and we worked on this solution together that we want to take you through. For the solution that we want to take you through today, it's one of the most common issues faced by an insurer. An insurance agency's website is an essential tool for attracting leads, prospects, but evaluating leads is a whole other story. Some leads may not be ready to use agency services immediately. Others may not be ideal customers. So lead scoring can help us distinguish promising leads from unqualified ones, saving agencies time and money. In this session, we will deep dive into how we can obtain insights from web data, such as which landing page are the most valuable for conversion purposes during the sales funnel, or whether access to downloadable content leads to conversion, or if marketing campaigns associated with a visit make a difference. All of this while the customer is still with us on the website in the same session, that is within seconds. Jumping to the business problem overview, we are here talking about a Swiss insurer It's a leading insurance company based out of Switzerland. And one of their problems is that they have a lot of traffic on the website and they are continuously trying to customize customer journeys. It becomes very difficult to personalize anything when you don't know who your customer is. Since most of the traffic on their website is unknown customers who come to the website only once or twice, it's very difficult to build a deep customer profile, let alone build a machine learning model to activate on. Now, most of these anonymous visitors come to the website to get a quick indication of the insurance rate by filling out a form. This means that the insurance provider will only have a limited amount of information to personalize any campaign. This implies that the prospects are often targeted with irrelevant messaging, and insurance provider is unable to prioritize targeting or optimize the spend. Also, there is no intelligence on the right channel for the customer. For the solution, I will hand it over to Kalai, who will take you through the solution and the architecture of the solution in depth. Over to you, Kalai.
Thank you, Marina. Yeah, so Adobe Experience Platform is the most powerful one, and it has the flexibility and an open system on the market for building and managing complete solutions that drive customer experience. The Experience Platform enables organization to centralize and standardize customer data and content from any system and apply data science and machine learning to dramatically improve the design and delivery of rich personalized experience actually. So we will be getting the personalized experience when we implement this solution actually. And the platform is built on RESTful APIs, and Experience Platform exposes the full functionality of the system to developers and supporting the easy integration of enterprise solutions using familiar tools. And enterprise platform, I mean the Experience Platform also supports the partners to build and integrate their own products and technologies as need. This is a powerful and flexibility makes Experience Platform unique in the market. It gives partners and customers and the community of developers a foundation on which to build innovations that drive the experience business actually. So it will exceed the customer expectations, and they should be able to see their data in 360 degree view. That's how the customer, the real-time profile, it comes into the picture, and then where we have a background of Cosmos DB, the data to be stored over there in the system. So let's go into detail of this actually. So how we have implemented this solution with uh, to get the lead scoring of this for a particular person actually. So it's kind of a step-by-step use cases of that actually. So yeah, let's go into that website, and then we will be filling up our informations, and then we wanted to get the score actually. So I want to see a score of a customer behavior in real time. The logical starting point is to collect the data, yeah, in real time. So we have collected the data in real time, and then um, the Adobe tag management solutions will take all those informations, and then it will take that through Adobe Launch, and then Adobe Launch makes it possible to use the brand new Adobe Experience Platform web SDK extension to collect data straight from a website. It's a data layer to us actually. So and then map it against an XDM based schema. So we have an XDM based schema of JSON 7, and then it has been implemented into a backend of the system actually. Then stream into Adobe Experience Platform by mapping data against an XDM schema upon collections. A lot of time and effort is saved downstream actually. So here, so we have to create any modeling over here, and then in that case we will be doing a lot of modeling, and then how the data should be modeled, and then to get that and all. So the Experience Platform will makes us to help to take those uh, things actually. So every type of customer behavior and that is collected from the client side will be taken to our platform, and then that is an experience even to us actually. So kind of an offline POS transactions or cards or anything, the product views, or like if any insurance solutions are, they wanted to browse and then see it, and then those customers also we can capture actually. So because of this solution has been implemented into the system, and Adobe Analytics will take care of that to collect those informations via clickstream, and then it will be taken to a system, and then it will be how we are making this into an unified is like inside the Cosmos DB, and then we have this solution running in the backend, and then it will score us the results what we want actually. So the detailed explanation of this and then technologies which we have used in is coming in on our way actually. So what are the technologies we have leveraged here? So launch, experience agent, pipeline, unified profile, and data science workspace inside an Adobe Explain platform, and streaming segmentation and Adobe Target. So the launch will be like which I mentioned, to collect the data from a website, and then experience edge to collect the data in real time and push to a pipeline. So pipeline will be monitoring that in real time, and then we will be getting um, this solution. I mean, so it will collect data in XDM format and then push it to a unified profile, where the unified profile is our Cosmos DB, and all the web and offline data will be like captured inside the unified profile, and then we get a 360-degree view of that particular data and then solution to all those. Here, the data science workspace, which we have an option to analyze the profile, and then we can build an intelligence out of it, and then marketer can use it, and then they can inform to whether they will be buying it or intent of buy, or all those information can be captured over there actually. And so we can build our own model and export as well. So that way it is. And then streaming segmentation will capture the user enriched profile, which are coming from different areas like a website and from offline, and then it creates a real-time information to the segments, and then we can target those, and then using an Adobe target we can target those users, and then we can provide them a personalized messaging over there on the website itself actually. That's how the technologies what we leverage, and then how we have implemented this solution actually. So we have a Cosmos DB where it has, whenever I say unified profile, there we have a Cosmos DB in the backend, and then it takes care of everything. So this solution architecture is which we have used it, and then how we leveraged, and then Cosmos DB. And here we have a data sources is from Clickstream on web page and Adobe Analytics. We link all the data using unified identities as like a primary key which we have, and then it will be attached in the system in the backend actually. The whole things are happening under the Cosmos DB. So since we are ingesting a data through one unified identity onto the table, and then we stitch all those data using an ECID and other custom identities based on the customers use cases actually. So we have model hosted under the data science workspace, which have an capability to export that model into an ONX, and then on top of it we will have a API service for that, and then that API service can be hit over from I mean, we can hit that API with the information, and then from a website, and then we get the score output, and score can be stitched back to the Cosmos DB. So this is how the Cosmos DB we have leveraged, and then there we get the so as per the data unification under the Cosmos DB, the score will be attached to the profile and used for targeting the audience via Adobe Target based on the profile qualified, right? So we will be getting that particular profile will be qualified for a segment under the streaming segmentation what we created as segments, and then those users will be targeted, and they will be getting a personalized banners offers how we scheduled under the Adobe Target. So this is how we have implemented the solution architecture, and um, so maybe I can turn over to Marina. Yeah. So we have a demo. We have maybe Marina will be taking over now.
Sure, thanks, Kalai.
Yeah.
So we have a quick demo for you. This is a fictitious company called Mutual 365, which is an insurance provider. Kalai, if you could please click on play. Let's take a look at how customer 365, Mutual 365, sorry, uh, is optimizing customer journey using Adobe Experience Platform. An anonymous customer opens Mutual 365 website, visits the car insurance product page. The visit to this page is collected by the website and sent to Adobe Experience Platform in real time. The X-ray panel on this website showcases what happens behind the scenes. In the Experience Events panel, you can see car insurance product page is a part of customer's activity. This experience event is already linked to an identifier. Here it's the cookie ID or the ECID that is used to identify an unknown user. So when this customer continues on their journey on the website to the page to get the car quote, car insurance quote, and fill out forms that are needed to calculate the cost indication of the insurance, All of this data is linked to the customer's profile inside Adobe Experience Platform in real time. Now, as soon as the customer clicks on the Get Quote button, all of the data will be used to calculate this customer's propensity to buy a car insurance in real time, and a machine learning model uses all of the form fields as input parameters and writes back the propensity score to this customer's real time profile inside Adobe Experience Platform. This score is then available for activation in real time. So you can see the X-ray panel over here and the segment ID over here. So we can, and this is how, and this is the Get Quote button on the Mutual 365 website. This is where somebody would have to click in order to be able to send all of the data to Adobe Experience Platform. The platform will capture all of the fields that you see on your screen right now. And all of this will flow into the machine learning model that we've deployed in the data science workspace in Adobe Experience Platform. And it will be used for building the model and giving out the propensity scores. Now, you can also see that the car insurance sales score of 72 in the sales services panel and the segment membership overview. You can see that this customer now qualifies for a new segment in real time based on the score that was calculated. Now, calculating propensity scores is just one use case. This is the same information that can be used to optimize, say, personalized product recommendations or an expressed offer for every specific customer. There are a lot of things that we can do with this. Now, here you can see the hero banner personalized for Mutual 365 based on the propensity score and segment qualification. Let's have a detailed look at how this is implemented in launch. A rule is defined to trigger when a customer clicks the button. When the rule is triggered, data is collected from form fields as data elements, which are mapped against an XDM schema and will be ingested in a data set in Adobe Experience Platform. So you can see that by clicking the Get Quote button, a request is sent from the website to Adobe Edge. A payloader of the request has an XTM structure, and this uses ECID as the primary identifier. This payload is then stored in the car insurance interaction dataset in Adobe Experience Platform. This dataset is configured as a profile dataset, and as such, it links all of the payloads to the real-time customer profile. This dataset is linked to an XDM schema in which the structure and fields are defined along with the primary identifier. The dataset and schema then are used by a machine learning model through data science workspace in Adobe Experience Platform. What you see here is a Jupyter notebook, which takes all relevant data from the car insurance interactions datasets in the platform and uses a random forest algorithm to find patterns and signals with the goal of understanding whether somebody will go ultimately and convert or not. Now, the model is trained in data science workspace in Adobe Experience Platform and then serialized into an Onyx form and then deployed on real time. So this model is trained in data science workspace and it focuses on real-time scoring. So when a customer clicks on the Get Quote button, the payload containing all of the information specific to this customer is sent to Adobe Edge, and Adobe Experience Platform accesses that. All the score then gets generated using the data science workspace and is linked back to the segment. Multiple segments can be configured in Adobe Experience Platform, and these segments are activated for streaming segments. Now, this means that qualification for these segments is evaluated in real time. A specific segment will qualify for qualify a customer when it has a sales prediction of a certain score. So, if a certain propensity score, for our example, let's take scores between 60 to 80, right? And if these scores are assigned in real time, the segments get qualified based on these scores, and thanks to the native segment people core service that is available in Adobe Audience Manager or Adobe Target, these can be activated in real time, and banners can be customized and experiences can be customized on the website. Now, once the segment is available to any tool such as Adobe Target, it can be used to configure any activity. So here what you've seen is hero banner optimization or customization, but it can be used for a ton of other activities, and all of this in real time. And these are the various customizations that you see on your screen right now. These are the typical ones that most customers would want to do, but it could also include customized messaging, customized content, customized links, etc. With this demo, I would now like to jump into the data science solution and uh, take you through what we did. Now that we understand that we've created enriched data science, enriched customer profiles, let's look at how we created the model that set apart the promising leads from the others. So we analyzed customer journeys up until the first quote is generated and built a machine learning model powered by random forest algorithm, which predicted the probability for conversion with approximately 75% accuracy on the out of time test data set. We followed the typical machine learning workflow of data gathering, exploration, processing model, and finally deploying the best or the most accurate model. We leveraged unified profile services in Adobe Experience Platform to get customer one views. We analyzed these customer journeys on the web. One of the interesting things worth mentioning was that the data aggregation for this was tricky, I would say, because we could only leverage the data up until the first quote, get quote is clicked. Now, this means that for some of the customers, this journey can be long and convoluted, and we would have a lot of data at our disposal to analyze. For others, this would mean that the journey is very short and there's very limited data. Another challenge was that very few unknown customers convert on any session, and that leads to imbalanced class problem that we had to address before modeling. Moving on to the important features for modeling, we studied a host of features that stand out for predicting conversion. Demographics was, of course, one of the important ones. Age, gender, PIN code can be a reflection of the quality of lead. Other obvious features that were important were insurance code, base price of the model. We found that web behavior is also a major signal of the level of interest in a product. Number of visits on the web, session depth, time on the site shows how engaged a customer is. Recency of visit is another important signal. Pages browsed is of major relevance. So, for example, landing pages, site sections clicked on, download material accessed, or even the page from which a customer exits or bounces is of significant importance. It leads, and one of the things that we realized was errors on site is one of the important major indicators. It can create a negative sentiment immediately and can diminish the chances of making a purchase for anybody. So that was another important parameter. And finally, jumping on to the value delivered, one of the most important things for the customer here was getting data to insights to activation in real time, and that is what we were able to achieve with this solution. It was possible and to a great extent made very easy by data being at one place, all together collated in XTM schemas in Adobe Experience Platform. Data science was at the core of the workflow, and we knew that targeting was always optimized. The best part was that all of this could be done for unknown visitors on the website. That really was the value for the customer. I hope you found this session interesting. Please let me know if you have any questions. Thank you.
Thank you. Thank you so much, Kalayarasan and Marina. It was really good to see a real customer application that you have built and gone through. few questions that did pop my mind, and I think few others as well, as we see, is why did you choose Cosmos database as your core database engine? And presume this is more a long stretch project, so you probably use the transactional database as opposed to the analytical store. And how has been your experience directly querying out of the Cosmos DB's transactional store?
So yeah, so we have a Cosmos DB, and then it has been built on top with the query service actually inside an Adobe Experience platform. So the backend of this architecture is on Microsoft Azure and with a Cosmos DB actually. So the solution is to utilize the Cosmos DB under the Adobe Experience platform. So this has been designed to have this unified feature, and as well as to query that in real time, and then make it faster actually. After implementing this solution, we have seen we are getting the results in milliseconds actually, so that we are sticking to Cosmos DB instead of using that other databases as well actually. So kind of we get the solutions in near real time, and then we should be able to see this 360-degree of view without any issues.
And your upstream data sources, are they a mix of relational and non-relational data sources, or did you have to specifically do some sort of data massaging, or holding a data in a different placeholder to transform data into Cosmos database?
Exactly, we have done that, and for that as well, we have taken from a different sources, like from offline, like an unstructured, from packet files or different formats. Actually, we have taken into a system, and then it stitched those data into the platform, and then we are able to see the different events and as well as the profile from a different sources actually. So from it attached under the Cosmos DB.
Sure.
I think we're at almost time, unless there was a couple more questions, Saranya, you had.
Yeah, no, I think this has been really good. Thank you. Now, it's really, really good to see a working demo. So totally appreciate that and your time. If we do have questions, we will put it on the chat. We will reach out. So audiences definitely do that. As we said, do tweet about these sessions at hash Cosmos DB Conf as well. And then we will now go on to the last session for the Asia time zone. Over to you, Ben.
Thank you.
Cool.
Thanks, everyone.
So, yeah, so for this last session, we're going to have Nazuzuki-san and Tesoro talk about designing, implementing Cosmos DB change feed architectures, which is we're saving the best to last. No, as we get a lot of commentary around the Cosmos change feed, and it's very, very popular. So we're going to have Neo-san that's going to be talking about this session, introducing and helping with the questions around this in Japanese. And yeah, I'll hand it over to Neo-san and Kazuki-san and Tesoro to discuss around implementing change feed.
Yep.
And this will be a fully Japanese session. So over to you.
はい。
Nice.
それでは、ここから日本語のセッションに移っていきたいと思います。ですね、コスモス DB コンフ、3つのタイムゾーンでやってますけども、このアジアタイムゾーン向けの、この2時間半ですね。この最後のセッションが日本語のセッションになります。そして、スピーカーはですね、日本が誇る Azure MVP2 名の方にご登壇いただきます。1人目は、三宅和之さんですね。そして、2人目、柴山こと、柴村達郎さんの2人に登壇いただきます。で、内容なんですけども、コスモス DB のチェンジフィードを使って、ラムダアーキテクチャの、をどう設計するかというところを、リアルワールドな、シナリオに基づいてご説明いただけるということになっております。で、これを見ているですね、日本語をご理解いただける方で、LearnTV を見られている方はそこでチャットがありまして、そこに質問を投げると我々に届くことになりますので、もしご質問等あれば随時、LearnTV のチャットでお伝えいただければと思います。それでは、三宅さん、島村さんお願いします。
はい、よろしくお願いします。
はい、よろしくお願いし
ます。画面はシェアできてるのかな？大丈夫ですかね？
どうかな？
はい。では、デザイン&インプリメンテーション、Cosmos DB チェンジフィードセントリックアーキテクチャ、ちょっと長いタイトルなんですけど、チェンジフィードの、Cosmos DB のチェンジフィードを使ったアーキテクチャの話をちょっと進めていきたいと思います。でこのセッションですね、ちょっと前半後半分けてまして、前半私の三宅の方から、チェンジフィードのセントリックアーキテクチャの、設計とか戦略について、少しお話しして、で後半ですね、しばやにバトンタッチして、多分皆さん聞きたいであろう、実際にどうやって実装するのかとかですね、気をつけたらいいところとか、そのあたり、相当ここでしか聞けないようなノウハウ結構溜まってるんで、ぜひ楽しみにしてください。ではちょっと最初に私の方から、設計戦略の方ですね、チェンジフィードの話したいと思います。でこのチェンジフィードを使ったアーキテクチャって、多くのシナリオ、私もちょっとこうやって仕事で関わってると、多くのシナリオは大体ここにマッシブデータプロセッシングとか書いてますけども、大量データ処理を、例えば IoT だとか、その工場のプラントのデータを大量に取得して何かデータ処理をして、次の、アプリケーションになんかつなげていくっていうような、データのそのパイプラインのようなですね、仕組みっていうシナリオが非常に多くなっていて、ここ2、3年、このパターンで設計している事例がとても多くなっています。でそこでよく言われることが、ここにバランシングマッシブデータライティング&コンプレックスクエリって書いてますけども、このパッと見相反する大量データの更新と複雑なクエリによるデータの読み込みだとか分析っていうようなものをなんとか両立させたいっていうニーズが非常に高いんですよね。で、その時によく言われるのが、書き込みのパフォーマンスはでも劣化はさせたくない。劣化させてしまうと、最近のこのあたりのデータのパイプラインって、リアルタイムにどんどんデータが入ってきてしまうので、一回でもフェールしてしまうと、もう全体が崩れてしまう。そういった業務を前提としているので、パフォーマンスの劣化っていうのは絶対できない。させられない。それから、かといって、じゃあ、クエリを犠牲にするかというと、それも、非常に最近やっぱりデータの、見方っていうのが、多種多様なデバイス、それからツールで、見たいというニーズが高まっているので、そこも犠牲にしたくないっていう、ちょっと両立できないんじゃないのっていうようなことを、要求されます。で、かつやっぱりクラウドなんで、コストについては、使った分だけっていうよりは、このマッシブデータプロセッシングの場合は、処理した分だけ、コストを、適切に払うっていうような、そういったモデルを前提としているっていうのが最近の傾向です。で、従来どうしてたかというと、全部が全部というわけじゃないですけども、よくあらゆるパターンとしては、この両立させにくい2つのテーマを実現するために、結果的にですね、ハイパースケールと言われているような、もう非常に高価でリッチなデータベース、データストアを持ってきて、なんとか、お金で解決するような話じゃないですけども、力技で、この両立を、2つの相反する要求を両立させてきたっていうのが、よくあるパターンだったんじゃないでしょうかね。で、最近、この CQRS、どっかで聞かれたことある方もいらっしゃるかもしれないんですが、このクラウドのアーキテクチャパターンの一つである CQRS というデザインパターンを使って、この問題に解決しようという、実際の事例なんかも多く出てきています。私たちも実際このパターンを使ってよく実装してるんですけれども、この図の通りなんですけど、CQRS って何やってるかというと、一つの巨大なデータストアで全てを処理するんではなくて、書き込み側、左側ですね、ライトオンリーと書いてある書き込み側のコマンドと呼ばれている仕組みと、クエリー側、リードオンリーの仕組みをもう思い切って2つに分けてしまいましょうと。分けてしまって、それぞれ書き込みに得意なデータベース、特性を持った、何かそのサービスを導入して、クエリー側も同じですね、その分析ですとかデータの読み取りに特化した、データストアを持ってきて、それぞれ得意なものを得意なものにやらせてしまうという戦略です。で、その時に、このクエリー側の方は別の見方をすると、このマテリアライズドビューっていう、言い方もするんですけども、もう、その読み取りに特化したスキーマでデータベースを構築して、できるだけ、その複雑なクエリにシナリオごとに合わせて、もう先に物理的にデータベースを分けて用意してしまいましょうっていう、そういう戦略を組み合わせて取ることが非常に多くなっています。で、これをじゃあ Azure で実装するとどうするかっていう話なんですけども、いろんな戦略あると思うんですが、今日は Cosmos DB Conf ってこともあるんで、Cosmos DB を使った方法というのを紹介します。で、まずこのコマンド側ですね。書き込み側は、 大量データ処理に非常に向いていると言われているこの CosmosDB を使って、例えばデータの同時書き込みが増えても、スループットの調整で、パフォーマンスが劣化しないのが CosmosDB の特徴なので、パフォーマンスを劣化しないように、このコマンド側を実装します。で、ただし、読み取り側は別データベースを用意する。この右側にあるマテリアルズビューを用意するので、データの同居を取らなきゃいけない。ここが CQRS で必ず工夫が必要なところなんですけども、このデータの同居を取る仕組みも実は、CosmosDB のチェンジフィードを使うと簡単にできるようになっています。このチェンジフィードっていうのはデータの更新追加が発生したときに、その都度でイベントを発火させてくれる仕組みで、データを外部にフィードする仕組みですね。で、それをじゃあ受け取る側っていうのは、Azure ファンクションの CosmosDB トリガーっていう仕組みを使うと、非常に簡単な設定だけで、このチェンジフィードと連動して、リアルタイムにデータの更新に、トリガーにした処理を自由に作ることができる。で、それをここではイベントプロセッサーみたいな言い方をしていますけども、このイベントプロセッサーで、例えば何か他のデータベースに少しデータを加工して書き込みたいとか、それから集計用に使うので、集計しやすいようなデータに整形してから、集計専用のデータベースに書きたいとか、そういったことが、もう Azure ファンクションですから自由に実装できるわけですね。ただそのデータの取り出し口っていうのは、チェンジフィードと組み合わせることで非常に簡単にこれ実装することが。後でサンプルコード出てくるんで、こんなに簡単なのかっていうのはわかると思いますけども、非常に簡単に実装ができるように、しかもほぼリアルタイムにこのコマンド側とクエリ側が同期するような仕組みっていうのを作ることができます。で、この応用じゃないんですけども、今回チェンジフィードセントリックアーキテクチャっていうのはチェンジフィードを中心にしたアーキテクチャの話をしてるんですけれども、これどういうことかというと、一つ前のページで、あたかも一つのコマンドに対して一つのクエリみたいな図を書きましたけれども、実はそうではなくて、このイベントストアを中心にして、このチェンジフィードっていうのは、複数の、チェンジフィードを要するに同時にデータを出力することができるんですね。なので、例えばこの図にあるように、一つはリアルタイムにイベントを処理して、何か必要な、条件に引っかかった場合に、例えばシグナル R に連動して通知をさせるとかですね、モバイルアプリに、メッセージを送るとかですね。そういったこともありますし、それとは全然別の目的で、例えば Power BI を使って複雑なデータの集計をしたいよというようなニーズも同時に発生しますよね。ただ今まで同時に発生したものを両立させることはなかなか難しかったんですけども、これチェンジフィード複数発行できるので、型やイベントのリアルタイムの数値、型やマテリアルズビューを作って、Power BI とかそういった BI ツールを自由に使って分析してもらうと。それから、もしかしたらそれ以外にデータを何か永続的にアーカイブをして、また再利用するみたいなニーズもあるかもしれないです。これ複数どんどん追加していけるっていうのが、このチェンジフィードの特徴で、一番強みじゃないかなというふうに思っています。で、実際にそれを実現してしまっているもう素晴らしい例があるんですね。それが、この図にある通り、JF エンジニアリングさんという会社なんですけれども、ここでは、この図にある通り、真ん中にチェンジフィードを、CosmosDB を置いて、そこに、イベントハブ、左側には膨大なIoT のデバイスが控えてるんですけど、そこからもうずっとデータがですね、もう膨大なデータ量がリアルタイムに Azure イベントハブ経由で入ってきます。それを CosmosDB で一回受けるんですけども、やりたいことっていっぱいあるんですよね。やっぱりリアルタイムで何かしたい。それを Power BI で分析したい。それから後でCSV ファイルみたいなのに保存して、じっくり分析したいっていうニーズがあるので、それぞれ全然別のデータを作らなきゃいけない。それをここにあるようにチェンジフィードを複数用意して、実際に出力して、もう24時間ずっと稼働させていると。こういう事例ももうすでに出てきています。で、もう一つすごいところは、チェンジフィードの下の方にアンダーデベロップメントみたいなの書いてますけども、この全体のアーキテクチャ崩さずに、全然別の目的の機能をどんどん追加していけるんですよね。で、実際今これ開発をしています。で、そういった形で全体を運用したまま、同じデータを使って別の目的のものをどんどん追加していけるっていうのが、このチェンジフィードのセントリックアーキテクチャの、メリットでもありますし、実際に取り組まれているお客さんいらっしゃいますよと。そういう事例でした。では、ちょっとそこをどうやって実装していくのかあたりを、ちょっと芝居に変わってディープダイブをしてもらおうかなと思いますので、お願いします。
はい。それでは、今回実装した、チェンジフィードセントリックアーキテクチャの、詳細について、私の方からお話しさせていただきたいと思います。じゃあ、チェンジフィードは、 これまで、Azure ファンクションを使ったり、チェンジフィードプロセッサーを使ったりって形で、基本的には上のプッシュモデルっていうもので、使うパターンが多かったんですが、実際にはチェンジフィードを今、2つの、利用パターンが存在しています。はい、1つ目はもう、ちょっと先ほども言った通り、Azure ファンクションの Cosmos DB トリガーを使った、プッシュモデルですね。Cosmos DB に何かデータの変更があれば、その都度 Azure ファンクションが実行されて、ほぼリアルタイムで処理を行える。細切れになってデータが入ってくるんですが、そういったものが一つ、プッシュモデルというものが呼ばれるものです。データが細かく入ってきて、ほぼリアルタイムで処理ができるっていうものになるので、データの変換であったり、今回のようにストリーム処理ですね。そういったもうずっと流れてくるような、大量データがずっと流れてくるような、処理に関しては、この一つ目のプッシュモデルというものが非常に向いていると思います。で、この二つ目なんですが、ちょっと今、SQL API のみで、SDK もちょっとプレビューでのリリースにはなるんですが、プルモデルというものが存在しています。プッシュに対してプルですね。プッシュはもう、トリガーの方が自動的にプッシュしてくれるんですが、プルモデルの方は自分から取りに行く必要があります。チェンジフィードの API 的には両方とも API を呼んで必要なデータをプルする形にはなるんですが、この2つ目のプルモデルっていうものは、より、低レイヤーな API が用意されていて、チェンジフィード、Cosmos DB トリガーにあるように、リース DB とかでちょっと、ステートを保存するなど、ちょっと高度な機能は、用意されておらず、自分で実装する必要はあるんですが、このプルモデルっていうものを使うことによって、自分でどれぐらいのデータ量が必要かっていうものを制御することができます。なので、今、上のプッシュモデルの方だと、だいたい、100件とか1000件とか、データ量にも、1回のリクエストの、サイズにもよるんですが、1回で実行できる件数、データ量の上限というものが決まってるんですが、この下のプルモデルというものを使うと、1万件までは頑張って取るみたいなコードも簡単に書けるので、バッチ処理ですね。もう1回にまとめ、そこそこで大きなデータ量が必要な処理に関しては、この2つ目のプルモデルというものが使えるようになっています。じゃあ次お願いします。で、データトランスフォーメーション、データ変換とストリーム処理なんですが、基本的にはこの、プッシュモデルというものは、先ほどから何回も言った通り、非常に、低レイテンシー、リアルタイムで、ほぼリアルタイムで処理ができます。そういったものなので、ストリームデータ、もう常時流れてくるようなものに非常に向いています。で、この、プッシュモデルを使う最良の方法は、Azure ファンクションの Cosmos DB トリガーを使う。もうこれが、もう一番良い選択肢になります。リース DB など、チェンジフィードに必要な処理ですね。あと、エラーハンドリングなども、もう、正しい方法で実装されていて、すでに実績もあるライブラリです。もう基本的にはこの Cosmos DB トリガーを使っておけば問題ないです。で、注意点としては、このデータ変換や、ストリーム処理に関しては、非常に、データ量にはよるんですが、常時、もう大量のデータが流れてくるような場合では、書き込みですね、そこから先、何か処理は行うんですが、データ変換とかストリーム処理の後に、何らかの API を呼び出したり、別のストレージ、例えば、データ分析、もうちょっとマテリアライズビュー作成のために、SQL データベースや、さらにちょっとパーティションキー、Cosmos DB はパーティションキーの、パーティションキーというものがあるので、ちょっとそれをうまく変換して、もうちょっと集計しやすい形にデータを変換したいという場合ですね。そういった場合には、Cosmos DB に書き戻したりということをするんですが、そこで、非常に細かいトランザクションが発生するので、書き込みが非常に早いストレージ、RDB 向けに、このプッシュモデルというものを使うのが適切だと思います。実際に今回の場合は、SQL データベースだったり、レディキャッシュですね。そして、マテリアライズビューとして Cosmos DB に書き戻すということをやっています。で、このプッシュモデルのサンプルコードなんですが、非常にAzure ファンクションでの Cosmos DB トリガーのドキュメントなどでも、よく見るものだと思うんですが、本当に属性を一つ、Azure ファンクションなので、Cosmos DB トリガーという属性を一つ定義するだけで、 その特定のコレクションの、干渉して、何か変更があれば、データを自動的に取得してくれて、このファンクションがキックされるという形になります。で一応これはマテリアライズビューを作るみたいな、形の、非常にちょっと簡単なサンプルなんですが、書き込みに関しては、Cosmos DB SDK の、V3 というクライアントを使っています。これはバルク書き込みだったり、SDK の実装が、こちらの方が新しいパフォーマンス的にも優れているので、こちらの方を使うようにしています。で、これは簡単にパート初期を変換して、別のコレクションに書き込むっていうコードです。これが大体2、30行ぐらいで実装できるっていうのが、この Azure ファンクションと Cosmos DB トリガーを使うというメリットになります。じゃあ次お願いします。で、プッシュの方は、一般的によくサンプルコードで見られると思うんですが、このバッチ処理ですね。もう一度に、大量のデータ、100件とか200件とかじゃなくて、1万件とかもっと処理したい。メモリーの許す限りデータを取得して、何らかの集計処理など、アーカイブなどを行いたいっていう場合に、この、プルモデルの方を使います。で、ちょっとこのバッチプロセッシングの方に関しては、今ちょっと Azure ファンクションでは、ベストな選択肢、実装の選択肢というものがちょっと難しいんですが、現実的にはタイマートリガーですね。Azure ファンクションのタイマートリガーを使って、定期実行させるっていうものが現実的かなと考えています。実際に今回のアーキテクチャではタイマートリガーを使って、定期間隔で実行させて、プロモデルの API を使用して、その実行間に、書き込まれた、変更になったデータをすべて取るような形にしています。で、このバッチ処理が非常に効いてくる場面が、ブロブストレージやデータレイクストレージジェン2ですね。そういったところにアーカイブ、生データとしてちゃんと保存したい場面です。で、このストレージ、Azure ストレージの、GPV2 やデータレイクストレージジェン2っていうものは、課金がライトトランザクションの回数になっています。なので、プッシュモデルのように非常に細かい、変更があった都度、キックされるような、実装の場合は、ここのライトオペレーションが非常に多くなってしまって、ちょっと異常なほどコストが高くなってしまうのと、ライトの数が多ければ多いほど、それだけ失敗する可能性ですね。ストレージも、上限のパフォーマンスの、上限があったはずなので、そういったものに、できるだけ、触れないように、まとまった量を書き込むって形でやっています。で、トランザクションプライスは結構高いのと、4メガパー、1万件って書いてあるんですが、これ1キロバイトを1万回書き込むのと4メガバイトを1万回書き込むのは価格が同じなので、できるだけ大きいバッチで書き込むっていうのが、非常にコスト最適化にもなるので、そういった部分で今回プルモデルを使用しています。もちろんその定義実行しているので、リアルタイムで書き込みが行われるというわけではないんですが、アーカイブ目的は多少のデータの遅延が発生しても全然共有ができるので、そういった意味でもプルモデル、遅延が許される環境っていう部分でも利用ができると思います。で、こちらのサンプルコードなんですが、ちょっと今回タイマートリガーを使った、ちょっと簡略的なものですね。実際に継続トークンっていうものが必要になるので、それを使ってどこまでチェンジフィードを読んだかっていう処理を、チェンジフィードを読み込んだかっていうものをちょっと保存しておかないといけないんですが、ちょっとそのあたりの実装は、プルモデルの方は提供されていないので自分で組む必要があります。ちょっと非常にそのあたりのトークンの、読み込みや保存っていう部分は、今回のこのサンプルコードから抜いているんですが、Get Change Field Iterator という、このプルモデルはイテレーターモデルですね、になっているので、そして終わりのないイテレーターですね。もう常時、ハズマーリザルトというこのプロパティがトゥルーになるような、無限に続くイテレーターになるので、それを使って、都度、必要な数だけチェンジフィードをずっと読み込んでいくことが可能になります。ただし、無限に続くので、ある程度どこかで打ち切りっていうのは必要になるので、例えば変更点がなくなったタイミングとか、上限、例えばメモリで処理できる、おそらく1万件、5万件までは処理できるだろうみたいな、そういった上限を用意しておいて、それでリミットをかけて処理を打ち切る みたいな、そういった工夫が必要になりますが、プルモデル自体も非常にシンプルな API 用意されているので、これぐらいで実装が可能となっています。で、チェンジフィードを使うと、非常に柔軟かつスケーラブルで拡張性の高いアーキテクチャというものを実現できるんですが、もう信頼性の高いアーキテクチャを実現するためには、この3つの要素が非常に重要となってきます。1つ目は、回復性を高めることです。で、2つ目は、べき当性と、結果整合性です。で、3つ目は、状態が壊れることを避ける。もう不整合な状態を避けるということ。この3つになります。で、回復性を高めるためには、基本的には Azure ファンクションのリトライポリシーというものを使用することになります。Cosmos DB トリガーは非常に便利なんですが、デフォルトエラーハンドル、リトライポリシーなどを使わない場合は、そのファンクションの実行が失敗すると、次のチェンジフィードのバッジに移ってしまうので、その失敗したデータですね、そこがちょっと失われてしまいます。なので、それを避けるために Azure ファンクションのリトライポリシー、このフィックスドディレイリトライやエクスポネンシャルバックオフリトライというものを設定することで、チェンジフィードを進ませることなく、成功するまでずっとリトライさせるという形処理が可能になります。これも属性を一つ足せるだけなので、もう今、Cosmos DB トリガーを使用している方は、設定をぜひ検討いただければと思います。で、2つ目が、べき当性と、結果整合性に、フォーカスするですね。もうクラウドサービスを使用する場合は、もうこの2つは非常に重要になってくるんですが、もう今回のアーキテクチャでも基本的には、実現できる部分はべき当性を非常に重視しています。ただし、べき当性、Cosmos DB や SQLDB の場合は、デリートっていうものが行えるので、トランザクションなり、そういったもので元の状態に戻すってことが比較的容易なので、これらのデータベースの場合は、べき当性を重視できるんですが、書き込みしかできないものですね。代表的なものは、ブロブだったり、データレックストレージ Gen2 なんですが、こういったもの、ストレージに対しての処理に関しては、基本的にはもう、べき当性を担保するのは非常に難しいので、結果整合性を重視します。正確には、必ず1回書き込まれる、必ず1回は実行されるというものに、取り組みます。このあたり、プルモデルを使って、チェンジフィードを進ませないという形で、リトライは自由に実装できるので、エラーハンドリングを適切に行うということが重要になります。はい。そして最後ですね。これは最近、個人的には非常に強くいろんなところでアピールはしてるんですが、不整合を避ける。もうそのためにはグレースフルシャットダウンを正しく実装するって形になります。Azure ファンクションは、サーバーレスで非常に便利なんですが、新しいアプリケーションをデプロイしたり、プラットフォーム、OS だったり、アップサービス自体のアップデートで、たびたびAzure ファンクションの上で動いているアプリケーションというものが再起動されます。そういったときに、例えば Azure ファンクションで、プルモデルを使って、バッチ的な処理が動いているときに、再起動が走った場合、じゃあどうなるみたいな。そういったところまで考えます。そのためには、グレースフルシャットダウンを実装して、そういった不正誤な状態になることを避けます。そして、さらに、リトライポリシーを組み合わせることによって、回復性も同時に高めます。なので、基本的にはこのグレースフルシャットダウンは、キャンセラレーショントークンっていうものと、このリトライポリシー、フィックスドリトライやエクスポネンシャルバックオフリトライっていうもの、この組み合わせで実現するのが非常に回復性も高く、全体としてのアーキテクチャの信頼性を高めることができます。はい。で、ここまでの3つの点を実装することによって、回復性高い、信頼性の高いチェンジフィード中心アーキテクチャを今回実装して、ほぼノートラブルで、稼働を続けています。で、ここまでの、話なんですが、マイクロソフトの Docs やGitHub などに、非常に、充実した資料がありますので、ぜひこちらの方を参考にいただければと思います。はい。じゃあ、私の方からのちょっとディープダイブの説明に関しては以上となります。
はい。以上で、チェンジフィードセントリックのアーキテクチャのセッションでした。ありがとうございました。
りがとうございました。それでは、Q&A セッションというか Q&A の時間なので、いくつか質問をしてみたいと思います。ですね、まず最初の話なんですけど、イベントソーシングパターンのイベントスタートして Cosmos DB を使おうという話と、その後の、なんとかな、GQRS というところの、クエリというかいろんなプロセッサーにある種タブサブ的に多数の、プロセッサーに対してそのチェンジフィードを伝えられるっていうアーキテクチャだと思うんですけども、例えば紹介いただいた JFE さんでしたっけの事例で、もしチェンジフィードがなかったらどんな感じの実装になって、どれぐらい大変になったかみたいなのって。
これ実は最初はチェンジフィード使ってなかったんですよ。
そうなんですね。
そこではやっぱりSQLDB を使ってたんですけども、そこが、さっき従来型って言ったように、ものすごいコストに実際になってしまってまして、でちょっとコスト以上に、やはりその、クエリにちょっと処理に限界も出てきていて、特に IO ですね。CPU よりも IO、データベースの IO に非常に負荷かかって、ちょっとかなり厳しい状況になっていて、これ以上はデータ、増やせないんじゃないかっていうような限界に達してたというのが現状ですね。はい。
了解です。そしたら、もう一つですね。タイトルにラムダアーキテクチャって入ってたと思うんですけど、その心は多分バッチ型の、プルモデルでデータレクとかプロブに持っていくと、そちらが分析用のものになって、コスモスのスピードレイヤーというか、ホットパスのだと思うんですけども、これも、そうだな。例えば、チェンジフィードがないときは、どんな感じの実装になってみたいな。比較できる。
もう、やっぱり同じなんですけど、SQLDB を、要はトランザクション処理と分析処理両方に使ってやっていたっていうのが実情で、そこから、ダウンロードするようなプログラムを作って、DB からファイルを生成してみたいなことをやっていたので、確か検索制限とかつけざるを得なかったんですね、確かね、これ。そう時代はね。
そうですね。あと、やっぱり基本的にチェンジフィードですね、今回の Cosmos DB を中心にすることによって、データの流れが一本化されるっていうところが非常に大きなメリットかなっていうのは感じてはいます。例えば、今回の CQRS のパターンですね。イベントハブ使って複数のサブスクライバーがいれば、確かに実装はできるのかもしれないんですが、あとはイベントハブが一つで受けて複数のストレージに書き込む。一つのファンクションが、SQLDB に書き込みつつ、データレックストレージに書き込みつつみたいな実装はできるとは思うんですが、そういった部分は一つの Azure ファンクションが複数の責務を持ってしまうので、非常にリトライとかが難しくなるんですよね。信頼性を高めることが難しい。SQL は書き込みが成功するんですが、ブログの方に書き込みが失敗した場合、じゃあどういうふうに戻すべきなのか。リトライをどうするかみたいな。例えばその逆もあり得るわけなので、そういった部分を一つのファンクションで持たせるっていうわけではなく、チェンジフィードを一旦 Cosmos DB に書き込むことで、それぞれのファンクションが自分の必要なタイミング、必要な流量でデータを取得するということができます。で、さらにデータは Cosmos DB 一つ、もうそこバラバラになるわけじゃないので、絶対同じデータなので、そういった意味でも一貫性っていう意味で、非常に、今回のアーキテクチャは、全体としてのコード量も非常に少なくなり、リトライも非常にシンプルな戦略でいけるようになり、基本的にはいいことだらけって形になっています。
なるほど。もう一つ、ちょうどリトライの話が出たので、リトライポリシーの質問したいと思うんですけど、Cosmos DB トリガーでトリガーされたファンクションに、リトライポリシーを無限に設定するって話があったと思うんですけど、そのファンクションから書き出す先のデータストアが比較的長時間にわたって障害になってしまうような時が、可能性としてあると思うんですけども、その場合に無限にリトライし続ける処理が無限に溜まっていくと大変だろうなと思うので、サーキットブレーカー的なものも必要なのかなと思ったんですが、そのあたり、どういった場面なのかなとお聞きしたいです。
はい。そこに関しては、エクスポネンシャルバックオフリトライっていうリトライポリシーがあるので、そこで、クラウドの、障害に適したリトライ処理っていうのが、最初から行えるようになっています。
リトライ間隔を長くするってことね。
はい、もう長くします。はい。もうサーキットブレーカーも、 当然ながら実際できるんですけど、基本的に、チェンジフィードの場合は、コスモス DB にデータが溜まってる間は、必ずそこからリプレイができるっていうメリットがあるので、正直あまり長時間止まったとしても、大した影響、ビジネス的にはそういう影響は確かにあるんですが、回復するまでっていうのはあるんですが、実装的には、コスモス DB に例えば TTL で7日間とか1週間とか2週間とか溜まっていれば、その2週間の間は別にSQLDB が完全に死んでいたとしても、その途中から必ず一貫性保った状態で復帰できるので、あまりそうですね、重要視はしていなかったりします。そこのリトライ間隔の設定だけで十分対応できるかなという部分ですね。
了解です。それでは、ちょうどお時間もいい感じなので、Q&A はこれで終わりにしたいと思います。それでは、改めて、三宅さん、柴村さん、ありがとうございました。
はい、ありがとうございました。
Okay, thank you. We are back.
Yep.
I wish I
Thank
learned
you.
Japanese.
Thank you.
Device session. I'll change CQRS.
Without change feed and Cosmos DB. Yeah.
Very, very good
Yeah.
presentation, guys. I was able to sort of follow along briefly from looking at your slides to figure out the context. But yeah, my Japanese from high school certainly wasn't up to scratch to understand what you guys were saying. But yeah, great presentation nonetheless, I'm sure.
Thank you.
Thank you.
So we've come to the end of this segment, which is the Asia time zone part. We'll take a short break, and there will be the next time zone, which is the EMEA, the Europe time zone friendly session, starting maybe in another 3.5 hours from now. So you have that on the live TV, on the YouTube channel, and also at godcosmos.com/conf. So you have it in all these places for you to go and latch on. Here's like a quick wrap up, Ben. Do you want to kind of have a very quick chat as to your run through highlights of today in terms of the sessions that went through, starting with HTAP, Cosmos for SQL, GraphQL, customer Adobe coming and talking about real-time scoring, and then of course change feed, which is more like our old but surely steady friend. What's been your thoughts? Yeah.
I think we had a very good assortment of sessions this afternoon. We sort of had the session focused on with Martin around the SQL developer or SQL database admin or the relational database person going to NoSQL and what they need to look out for. So I think it was a good round out of topic for those people. We catered for the data science people through two concepts, really. One through the analytical queries, which Will was talking about with Synapse Link, and also through the real-time scoring and stuff as well with that presentation with I'm not going to be able to pronounce his name correctly, unfortunately. And I thought that was great. And so those two things can go together very well. I also thought that the presentation around GraphQL with Aaron, with the demos always go down well. On the edge of my knowledge there, I have a good understanding of gRPC, but I'm not sure how that relates into GraphQL or whether they compete or they're separate sort of componentry. But I suppose all of it shows that Cosmos can be used across all these different layers in these different segments and can be an advantage to the solution that you're going to output. So I think some really good take-home messages from different sessions there that we can utilize moving forward, definitely for people watching this later on.
That's absolutely the case as well, right? Like to Ben's point, many of the sessions, as you see, Cosmos DB is kind of taken for granted. Like when we look at GraphQL over Cosmos DB, the focus was really about choice of using Azure Functions versus App Service, and then running that GraphQL in memory on Azure App Service, and then so magically connecting to Cosmos DB in a way that makes full stack development easier. So there was this good iteration of the fact about how database is so critical, but a really good solid database is when the applications can take the limelight or highlight to be able to connect to it seamlessly. Was again showed in the real-time scoring personalization with Adobe Experience Platform session. Most of the session was really about how did they actually do the scoring? What were the business parameters that they wanted to score on? And how did they set up their modules? But really, what is the fuel? Is Cosmos DB helping them with high availability in terms of low latency? They didn't have to use a cache. They were able to use the OLTP store, but able to run queries over that, so on and so forth. So yeah, I think to me as well, it's been really cool to see customers and people outside of the Cosmos DB team and Microsoft team being able to share and tell us things that went well and how we can do better, tips and tricks.
Yeah, and I think the part you touched on as well is with the real-time scoring or the analytical processing, that is require, or even from the GraphQL, because it's from the front end, right? These require fast, millisecond response times to get that information back quickly. And they're three different distinct use cases, right? So what that serving layer just shows the seamless integration of how Cosmos can report back fast and quickly. Whilst we didn't sort of touch on the ideas around geo-replication or the multi-master rights and the 5 nines of high availability, but that's what you get out of the box. And I think that's a really good sort of example of those different use cases. And not to mention change feed, of course, which was a staple granted feature in Cosmos, but that opens up the whole event-driven event sourcing, event-driven architecture, and then if you explore that further to Kafka syncs for Cosmos as well. So yeah, there's a lot of great stuff there that I'm sure some other people will talk about in some of the on-demand sessions that people can watch. Whilst we're waiting for the EMEA stream to come on board, there's a whole lot of on-demand sessions out of the go to cosmos.conf, and then you go on demand, and there's about 10 or 15 or whatever on-demand sessions that you can watch anytime.
Yeah, so thank you, all of you. It has been great to chat. Reminder again, feel free to tweet with a hashtag #CosmosDBConf and follow on with all the live sessions and the recordings. The European time zone isn't far away. We have some very interesting sessions coming up there. Integrating AKS, Azure Kubernetes Services on Cosmos DB, and how does that work? Azure Functions using serverless database programming model, that's coming up as well. We also have certain ISVs talking about data modeling. How do you choose schema, embed versus reference versus how do you work with a schema? And then really, how can you leverage the operational side of Cosmos DB, for which it's been well known till today. So some of really good sessions coming up. Stay tuned. Take a break. Until then, see you soon as well. Thank you very much.